Good morning, everyone. No, a little bit more energy. The Bangalore weather is the sunniest I've seen today. So can we get that kind of energy here? Good morning. All right. I've been told software engineers have a little bit more energy than this. I'm a BCom graduate, so if please prove me wrong. Can I hear some more, get some more energy from you guys? Good morning. Much better. Hi, my name is Sunil Suresh. I'm going to be the MC and host for the rest of this conference. First of all, congratulations on attending the very first Dataops Observability Conference happening in India for the very first time. So can we get a round of applause for that? So today on this stage, you're going to see a lot of data professionals, data leaders, an amazing lineup of speakers, a lot of fun things in your agenda as well. So if you guys would like to view your agenda for the day, you can just see your cards. There's a QR code there, and it'll redirect you to a landing page, which will show you the agenda for the rest of the day. Has everyone got their cup of coffee already? Yes? Anyone still hasn't? If you would like to take a moment to quickly go grab a cup of coffee, and we can get started with the rest of the day. I'm guessing everyone got their coffee, yes? Awesome. All right, guys, so just to kind of warm you up before the session begins, I'd just like to also give in a small set of ground rules that we'd like to follow through here. Normal conference rules. Number one, keep your phone on silent or keep it on low volume. It would really help. It would maintain the decorum of and be respectful of the speakers that are going to be gracing the stage today, right? And also save your battery, because we have an amazing quiz that's going to be taking place. And rest assured, there are prizes if you win this quiz. It's a very interesting way that you're going to be gaining. You're going to be walking home, hopefully, if you're a winner, with a gadget of a kind. Cool? So that's still in the suspense bit, but you're here. The lunch is also going to be amazing. We are at the Royal Orchid, Damlur in Bangalore today. So I'm excited for the lunch personally. So looking forward to that as well. Okay, so a little bit about me. I've been an MC for the past 7 years. And how I got into my MCing journey is through an art form called beatboxing. How many of you guys here have heard beatboxing before? Oh, that's a lot of hands going up. That's a lot of pressure on me. But hopefully, for those who haven't heard beatboxing, I'm sure I would do a good job. And those who have heard beatboxing, hopefully I've become the top beatboxer you've ever heard live. Yes? Would you guys like to hear that? No, I need more energy. That's like, I'm an artist, so I feed off your energy. So this is all I ask, is to be involved with my journey throughout this entire day. So can I get a loud yes? All right. Check. So what is beatboxing? This is where a human being with the God-given capabilities of making sounds creates music, right? And there are 3 simple sounds in beatboxing. The bass kick, which is me mimicking a drum kit, right? Which goes like, then the hi-hats, and the snares. And when you put it all together, you guys liking this so far? Yes? This is the kind of energy I want you guys to maintain. So clap with me and just warming you up some more. Let's loosen those shoulders. I know we've had a long week. It's Friday, right? But isn't it awesome that you get to meet new people? Yes? And you get a morning dosage of beatboxing. So let's clap your hands together. Let's go.
Thank you very much, guys. All right. So now that I've got your attention, let's see what the audience comprises of here. How many of you guys are data enthusiasts in the building? Put your hands up. All right. Awesome. How many of you are SREs? Put your hand up. Keep those hands up, all the data enthusiasts. I want to see everybody's hands up in the air. Data leaders, keep your hands up, keep your hands up, keep your hands up, all right? Data leaders, data geeks, yes? Now, this is the part where I hope everyone's hand is up, right? And I want you all to follow me. Cool? Thank you so much for interacting with me that way, guys. All right. So right now, I'd like everyone to go, ooh. No, from the heart. Woo! All right, this, whenever I point at you guys, you're going to do? Some of you got it, others, little lag, but it's okay. Let's fix that again. Let's go. Perfect. This is how I would like to thank the sponsors of the event. Can we say not ooh, together. 3, 2, 1. For Unravel, for organizing this amazing event. Please put your hands together. And also a brilliant job by the team from Confub for powering this event. None of this and none of us would be here. I wouldn't be able to grace this stage without that. So thank you so much for making this entire event happen. Also, I'd like to take a moment to thank our community partners, JetBrains and Fifth Element. So what do you guys say? Amazing, guys. A little bit more enthusiasm is slowly increasing in this space. So with that, I'd like to thank my favorite people here. That's you guys. All right? For this, I want you guys to, anybody in here knows how to whistle? Thank you very much. The gentleman with the cap. Yeah, okay, I'm seeing a lot of different whistles coming out. So for a small bit of beatboxing again for you guys, I want you all to clap again with me, all right? Club music. There are a few people outside. This is how it's going to sound for them. You guys seem like a fun audience. Are you guys ready for this conference? Yes? That's the kind of energy I'd like to hear as well. So, we're going to start off with our very first speaker for the day. Are you guys ready for that? And every time I point at you, you guys go? Yes, that's how Bangalore is, like a very hooligan state. I love it. Cool. So, just let me catch my breath, guys. Apologies. All right. So, the first keynote is going to be given by none other than Shivnath. Can you put your hands together for Shivnath? While he comes up on stage, let me give you a little bit about background on Mr. Shivnath Babu. He is the CTO and co-founder at Unravel Data. He's been helping to innovate and solve difficult challenges enterprises face with their data. Previously, he was a tenured professor of computer science at Duke University. How cool is that? Come on, guys. Yeah. So he's going to be driving the entire keynote. So once again, can we say, hi, Shivnath? No, not like we're in class. A little bit more like we're friends. Hi, Shivnath! Shivnath, they're saying hi to you. Would you like to say hi back?
Hi, folks.
Hi, folks. Yes, that sounds like a professor for sure. Handing over the stage to you, sir.
I don't need that. I can use this. Yeah. Thank you. Hello, everyone. Can you hear me? Can you hear me through the microphone? It's probably not through the microphone, right? Awesome. That's much better. So I'm Shivnath Babu, and first and foremost, I want to thank everyone. It's all good. Fantastic. People have told me that I usually don't need a microphone, but this time let's use a microphone. Again, everyone, I'm Shivnath Babu. I'm CTO and co-founder at Unravel. I would like to thank all of you for coming here. In fact, let me try to outdo like Sunil in this keynote, but thanks everyone for coming here. I was actually, when I was prepping up this talk, I was thinking like, there used to be a time, maybe 3 years back, literally every month, I'd be doing at least 1 or 2 such talks. Because again, my background, I'm also a professor of computer science at Duke University, where a lot of the research that we did eventually became Unravel. Right? So today, what I'd love to do is tell you a little bit about it. But when I thanked everyone, I should absolutely call out the organizers. Right? In fact, there are a lot of Unravelers right here in the audience who did a stellar job enabling this to happen. Right? We are a lot of the time. Yes, I would love to. Thank you. Thank you. Terrific. So now getting on to some of the things that I would love to tell you more about. Right? I'm sure all of you are here because data is really becoming extremely important to every enterprise, every industry. Every industry is being transformed by data. If not, it is going to be. And we are going to see a lot of innovation. We are going to see a lot of disruption, like where people doing things with data are going to make a difference. Right now, I like to say, somebody famous had said that software is eating the world, maybe 15, 20 years back. But today I'll say it's data that is eating the world. But complexity is actually affecting the effectiveness of people working with data, data teams. How many of you here can claim they're part of a data team? Raise hands. At least 50% of the audience, if not more, is part of a data team, right? So what is going on, right? As data teams try to do things with data, you run into many kinds of issues. Say that data is not clean. How can I even trust the data, right? From that to, I've created my first application, I'm running it, it fails. And I have no idea what happened, right? Or I'm trying to migrate it from an environment where it's running to the cloud. But seems like results are wrong. I'm not meeting my SLA. Or costs are going high on the cloud, right? A lot of these issues are literally, they are blocking data teams from becoming effective, which is something we should be concerned about, because it is these teams that create innovative applications with data, right? They create the effective cures for diseases. They make transportation very, very easy. I can't imagine how the world would have been, right? The world I was very used to without an Uber and Ola and things like that, right? Everyone. So the data teams needs to be very effective. So today, again, many of you may have wondered why this conference is called Dataops Observability. Dataops and observability are two big movements, concepts. You can think of it the way you want to, right? Which have really emerged to give some structure and some meaningful ways to proceed in this world where everybody wants to innovate with data, but they're facing some kind of blockage. Dataops itself, it is a spin on DevOps, which actually came and transformed the way in which people move apps into production. The same kinds of concepts are very similar. Concept being brought to the data teams to enable them to, from an idea onwards, to ship an app in production, right? Everything in between, a clear set of principles, a clear set of guidelines or best practices. That's what DataOps is. Now, as I mentioned many times, data teams get stuck, right? And the observability side is how you understand what is going on, make things much more essentially demystified or decoded, so you can pinpoint root cause of problems and fix it. So data ops and observability, two big themes, right? And we felt there is a lot of like symbiotic relationships between them. So let's bring them together. People are trying to make great things with data and trying to follow a set of practices, new practices, and they're also trying to use tooling to make things easier to manage, easier to understand. Let's bring that together. So hence, data ops and observability, right? So in the next, as the clock says here, 19 minutes, right? I'll try to establish a little bit more of this. And I really, again, I'm sure questions will come up. Please hold off your questions towards the end. I'll finish, and then I'm here. The lot of you like will probably have not only questions, also things to contribute and how you're making a difference in this world, right? So let's take actually the journey of an application, right? Because applications finally extract value from data. Let's pick an application. Just imagine we have Linda, a data scientist. How many of you actually label yourself as a data scientist? I'm sure a lot more of you, but I'm seeing a good chunk of hands, maybe 10% of your hands, right? Let's have Linda, a data scientist. So Linda, she's a data scientist. She's working with data, right? She comes up with a great idea to work with, like, a data related to marketing, and she feels that can make a difference. So Linda, and I'm sure many of you data scientists, right? You're great Python, like, coders. She creates an app which is really a dashboard, a data-driven dashboard in Python. Linda shows it, and very excited, she shows it to her boss, product lead Amy. Amy gets excited. Wow, this is great stuff. But I want you to bring like more data. This is just with some toy data sets you're showing me, like get more data, right? Oh, now I need to work with more data. So Linda says, how do I work with more data? And I need Spark. Spark is a technology that can handle larger amounts of data. So she brings in Spark. She starts running Spark now. The dashboard is now on Spark, right? So it's handling large amounts of data. So this is fantastic. But this dashboard will have even more value, even more ROI if you can combine multiple data sources instead of just that one data source you're working with. Okay? Bring in more data sources. And as many of you know, right, when you bring in more data sources, you need some way to orchestrate them, connect them. So enter some kind of orchestrator like Airflow to combine these data sets together, right? Spark and Airflow. Now the dashboard is now richer, more data sources. They present it to the CMO, the Chief Marketing Officer, Mark. Right? Mark says, fantastic. Like, can you make it more real time? That's a great dashboard you're kind of generating. But I want to see the results updated in like 15 minutes so that some decisions can be made based on that. So now it goes back. Oh, I need to like make things more real time. Oh, I need Kafka so I can get and process this data in real time. But this is where her expertise kind of reaches kind of a dead end. So she talks with Sam. Sam, you're a data engineer. Can we work together? Let's put Kafka in, Airflow and Spark and make this app real time. So Sam says, yeah, great stuff, but I actually think you can do better this transformation and things like that with this tool called DBT, the data build tool. So Sam brings in this tool. So now DBT, Airflow, Spark, right? PySpark. Sam says, well, if you need to move to production, we need to work with our Andy, our operations lead. So more people, NAP. And he says, well, don't run Spark on this small clusters and everything you're running. Let's bring Databricks, because Databricks runs this managed Spark, or let's bring in EMR, right? Great. So now everything is like nicely come together. Goes back to CMO. This is fantastic. This is very useful. Can we add a little bit of machine learning to make it more predictive, right? And as the story goes along, hope you realize what has happened, right? From that one idea to like truly get into production, it became a data pipeline. And any data pipeline you're building invariably will have multiple components. And we actually did a survey in a very similar venue, although it was virtual, almost a year back. And people said, look, our pipelines, our data stacks are made of like 6 to 20 systems. And how many in the audience can relate to this? My stack has at least 3 to 5 systems or more. Now, more hands than data scientists. That's fantastic, right? Very, very common thing that happens, right? Well, as these stacks now become multi-system, multi-platform, multi-cloud, multi-whatever, right, comes in complexity. One system itself is a little bit complex to handle, right? Imagine the interaction of multiple systems. And with great complexity, things can go wrong. What are some of the things that can go wrong? Maybe that pipeline that is powering like this application for Mark, right? He said 15 minutes I want these results to be updated. Maybe it's not meeting performance or SLA, right? And performance is not just about the speed at which your apps actually run, right? It's also the entire time it takes a team to ship new data products, ship updates to data products. So the agility of a team can be lowered because of complexity. And if you're running things on the cloud, well, maybe if you didn't think about it, there are a few of you were telling me that you're running 2,000 data pipelines, right? And who's managing all of them? So suddenly cost can increase. Or maybe some bad data got thrown in, some pipeline broke, and suddenly you don't know if you can trust your results or not. Any leader like Mark cares about at high level performance, and performance may be SLAs, performance may be the performance of his or her teams, cost, again, cost, similar fashion, right? Cost of infrastructure, cost of teams, and then things like quality of the data, quality of the results. So observability has actually come in as like, this is the answer to all of those challenges, right? So let's drill down. Like, observability is a very interesting term. It originated in control theory, actually, observable systems. And a system is observable. It could be a small system, it could be a large collection of individual subcomponents, right? Something is observable if, based on just its outputs, you can explain what the system did, what happened. If you start to apply that observability to our world, outputs get replaced by the telemetry data, right? All the monitoring data that you can collect, which very specifically in today's world are like logs, which are often unstructured, or events which are more structured, or metrics or traces of how things are, these requests and data flows are actually happening. So that's the origins of what observability means. If you map it to this world and now start to like relate some of the issues with this, what observability brings to the table, just imagine suddenly this dashboard that was earlier refreshing within 15 minutes became slow. Now it's running in 20 minutes or more. SLAs are not being met. Mark is unhappy. And he's tasking Linda and Sam and Andy to kind of troubleshoot the problem. And they have this observability solution, right? They're trying to understand with these events and logs and metrics from all of these systems. It's actually not easy to take individual logs from different systems and correlate everything together to understand and troubleshoot what happened. Imagine the system is very complex, right? It's a multi-component system. Logs, will you look at Airflow logs? Will you look at Spark logs? What do you even look at? So if you think about what could be even better, what could be a better observability, right? Rather than just give me all the events, logs, traces, and metrics. Wouldn't it be great if something could take all of those events and logs and metrics and stitch them together in a way that Linda and Sam and Andy can make sense, because they know their data pipeline. We have all the logs and metrics. Something can just like correlate it together, that here's how the end-to-end pipeline behavior kind of looks like, right? That would actually make their life so much easier to understand, troubleshoot whether the problems in Spark or in Airflow. What could be even better? Suppose along with doing all that correlation, this observable system, observability could actually, that solution could tell you, look, I did some identification and I'm seeing that this thing changed, or here I'm spotting an anomaly, right, with respect to some baseline I've built. Some kind of patterns that you can automatically extract from the data. What that will help these folks is actually, instead of wading through all the logs and trying to understand what the pipeline is doing, they'll be kind of guided towards where possible problems or issues are. If you think about it, what could be even better, right? What if this observability system or solution could not only kind of do these patterns and things like that, but could itself use some AI or machine learning or data science or whatever it is, right? And then not only tell you that this is what could be wrong, but this is what I think is wrong, even better, here's what I think is a fix you can do to fix the problem. Right? It will be something which will help these folks significantly. what could be even better? What if the entire system itself was self-healing, self-tuning, right? If it knew how to understand what is the cause of the problem, can't it fix it itself? This is what I like to think of as observability, which is often related today with this events, log, metrics, and traces getting into place. There are many more things that we could do on top of that data to make things easier and better for the personas involved in troubleshooting all of these kind of issues or making things better. So that's beyond observability, right? And I want to actually point out an interesting analogy in the world of transportation, right? Earlier, people used to walk back in the day, right? Then they realized I can make myself more efficient. I can get place A to place B faster by running. And then came, well, instead of why am I running? I can use a horse and let it run, and I'll get to my destination faster. And as things evolved, well, the motor car was invented, right? Which was supposed to be a faster horse, right? But it's using an entirely different way of thinking about getting from place A to place B. And now we have self-driving cars. In a similar journey, right, can we actually take in this entire world of observability? And let's see it in action, right? We talked about a lot of concepts and things like that. Let's see how it might actually play out in this real environment. And we actually had a real use case, right, which is our data, product leader, Mark. He was relying on a dashboard to make all of these real-time decisions. He wanted things to be done within 15 minutes, but this dashboard is taking a much longer time to refresh. So it's not able to meet his goals, right? So real kind of problem, one among the many kinds of issues that data teams deal with. So for this one, how will all those different going from the basic observability of getting all the data in a single place to making things like self-driving or self-healing, how will that play out? So with the event logs and metrics and traces, again, don't get me wrong, it's extremely important to get all your data in a single place. But any of you who has actually tried to work on these kind of things, you probably see that if I get my logs, I may have a log search engine, but I need to know what I should be searching for. Nothing is telling me what to kind of search for, right? Maybe I have a lot of metrics and I have too many metrics. And if I'm a data scientist, I probably don't even understand 90% of what those metrics are, right? Or these traces, which may be Java, heap dumps kind of thing. They're all useful data. But if you're trying to troubleshoot problems with that, right, it can take a long time. It takes many people, and sometimes you don't even get your answer. So from that, we said, hey, what if something could actually in that data pipeline world, right, could stitch all of these things together? I'll show you a few screenshots. Those are taken from the product that we love and we are building, but it's mostly for illustration, right? So here, this is actually that same pipeline that Mark was actually looking at. If you look at on the, it may be a little bit hard for people in the back to see, right? But if you look at the very top, it's actually saying this is your entire workflow, but in that entire workflow, here is a component which is actually becoming the bottleneck, right? So stitch all that entire workflow and all the components and things like that together. And in this workflow that Mark's team had actually built, right, there were 8 jobs. And job 3 was the cause of the problem. So once you put all the data in that kind of a visual, right, it becomes easy to understand. You don't need to be an expert in Spark or Airflow, right? You can understand this could be coming from Airflow, it could be coming from Azure Data Factory, it could be coming from your Tidal, enterprise schedule, it doesn't matter. But ultimately, that workflow breaks down into jobs, and something could become the bottleneck. You pinpoint what that bottleneck is. So that is what the extraction of from all these logs and traces, right? Here's a pipeline entity. That pipeline entity has these 5 job entities. This job is running in this Databricks cluster and it's taking this much amount of time, right? It's just a fairly conceptually easy way to think of how these things can come together and how these things come together and can be extracted from data. Now, we said things could be even better, right? If it can do all of these things, why can't it start applying some kind of learning algorithms on this data and then say that, look, actually, I found that is a bottleneck. To fix the bottleneck is running with a configuration like this, and I'm positive that you can read this, which is okay, right? I'll just verbally explain what it is, and all the content should be available after the conference as well, right? But by analyzing this data, it can actually say, look, I study the configuration. The configuration is in a certain way. It's not for the new changed data size. You need to have a different configuration. It can give a very actionable recommendation. And then this is a world ripe for a lot of innovation. Recommending good cluster topologies, good node configurations, good SQL level constructs. People write, I'm sure a lot of you have seen horrible SQL that is written, right? And not because the person is really malicious, but business analysts don't know all the nitty-gritties of writing good SQL that can run on petabytes of data in a large cluster. So a lot of innovation can be applied to build models that can capture these things and suggest, even guide the user towards the root cause of a problem is not the data, it's actually the resources, or it's not resources, it's the scheduling part when many things may be getting scheduled together, right? A lot of room for innovation like this. But again, as we said, things could be even better, right? A bunch of these problems can be detected not after it has happened. So it's no fun to detect the problem after your SLA has been missed, after your budget has been overrun, after you have spent all the cost on Amazon or Azure. They're not going to give your money back, right? So can these be caught proactively? Right? So this is a kind of an alert which can say, look, I know your SLA will be missed. And why do I know that? Because I have your full history, right, of every run and everything that's happening, and I'm understanding and analyzing that. Just like I'm sure many of you are building your machine learning models to improve click-through rates or sell more products. In this world, also we can apply a lot of these machine learning to detect problems before they happen, so that teams or even automatic systems can scale the cluster, change the resources, things like that, and ensure that the problem doesn't even happen. So these are the kind of things which can take this world where my SLA was missed and Mark is not happy to a much better world. A world where at least troubleshooting and things like that are quicker and faster and much more structured, rather than everybody here are logs, go figure out the problem, right? To building these self-healing, self-tuning systems which can prevent these problems from happening. And I'm sure all of you were probably waiting for the climax of this particular movie, right? In this movie, Mark eventually became happy because the SLAs from the time of actually 23 minutes, it went down to 11 minutes, and he's happy. But he could have been happier if that problem was actually detected early and fixed, and he never even came to know. The user, the consumer, your customer doesn't even see the problem. And those are the kind of things that are possible in this world where if you start thinking observability, and in fact even beyond observability, bring the wealth of data analysis, machine learning, artificial intelligence to work on this data, right? Now, a key observation we had as we went through this journey ourselves, right? And I've gone through this journey in a sense 2 times. As a professor, while we were working on this problem and doing intense research on it, and then taking this technology out to the world and working with a lot of real practitioners and customers, right? One thing that emerged is, this journey of going from logs to automatically extracting entities from the data, to applying algorithms to detect anomalies and baselines, to applying machine learning models, and sometimes even just straight up rules to guide the user towards the cause of the problems or the fix, and eventually building something that is auto-tuning or self-healing. You can sort of think of that journey in a little bit simpler words, right? The simpler words are, what is observability? And everybody has their definition of observability. Our definition is, if it is observable, an observability solution or observable system is telling you that, look, I will make it easier for you to understand what is going on. I'll make it easier for you to troubleshoot all the problems and things like that, but you have to decide what to do and how you're going to do it. I'll help you because I'm bringing the data together, I'm analyzing it, right? And beyond observability, the first thing, that is optimization. And optimization, again, is a loaded word, but if you can think of it as, the system doesn't stop by just being observable. It'll tell you that here are some of the things that are going wrong and here's how you could fix it. But I'll still not fix it for you. Governance is the holy grail. Governance is where you can define your policies, you can define your SLAs, you can define your budgets. A system will kind of watch out and help you not even overrun it, and those problems may not happen, right? So beyond observability is optimization and governance. And as we saw earlier, what do data leaders care about? They care about performance, performance for applications, performance for their own teams, cost of the infrastructure, cost of their, like running their own teams, and quality and correctness. If you bring all of these things together, you get this nice 3x3 matrix, right? Performance, cost, and quality. Those are what people need, right? Observability, optimization, and governance are what you can provide to make their lives better. And each of these individual boxes is actually building that is a challenge, right? And ripe for innovation. You can take, I'm going to do observability for performance and cost, or I'm going to do optimization for cost, or I'm going to do governance for data quality so that data quality issues get nipped in the bud and your pipelines don't fail. But it was even more interesting to think like, can we build something that can do all of this? Those are the kinds of challenges that people who are focused on observability and data ops can come together, work on these things and make happen. And that is exactly the reason why we want to host a conference like this, bring a stellar like a set of minds like what I see in the room together, and begin an entire journey around great minds, produce great solutions, and let's make our data teams very efficient so that truly data can eat the world and we can have innovative solutions. Thank you. Happy to take questions. I saw my time has run out, but
Hi, anyone with Q&As? Yeah.
Thank you for a wonderful session. How this observability is different than monitoring? Both are doing the same job, it looked like.
this is one of those fundamental debates that don't have a single answer, right? A lot of people say observability is really that old wine in a new bottle, but the old wine is monitoring, right? That's that school of thought. But personally, as I think, and having worked on this problem for a long time, right? In monitoring, a lot of the time our focus was just like extract the metrics, like put it out there so that somebody will use it. Observability even starts by saying like, see, the core thing about observability is I want to make the system observable. So somebody can explain what happened. So yes, they are very, very related. They work with exactly the same data, but the goals in observability are slightly more, I would say, refined and connecting towards the true use of what the monitoring data is compared to monitoring. But a school of thought can say like it's monitoring was also like nobody said monitoring is just simply collecting data. That data is collected for a reason. I don't have a point of view very specifically. I think just the word observability makes us think about these problems more, because what is really needed is more minds, great minds, think about this problem and solving it to make data teams more efficient. I would take more, yeah.
Hi, Shivna. Thank you for the talk. It was, really insightful. A large section of the data problems that we see on the ground are because of data quality, and these are what we call as silent failures. They do not manifest themselves as necessarily errors in the pipeline or the SLA misses, but they manifest themselves as, for example, the active user count of a product dipped, a lot in this day, which shouldn't happen given the amount of traffic that we have seen. What does even auto-healing mean in that kind of a space? Because this is where, the source data, for example, doesn't have the right data. Can we even do auto-healing? I understand the auto-healing and auto-remediation or self-healing that you talked about for errors that happen, but what about the silent errors?
Yeah, fantastic question. In fact, I'll actually point you to a term which I first heard from the Intune team, which is this notion of a circuit breaker, right? So the point is, again, what is the question is saying, like these data quality problems, correctness problems, right? They are just so hard. Is it even possible to build a self-healing, self-tuning system, right? Now, a lot of the time, again, it's not about can we build a self-healing system. The short answer is like you can never build an entirely self-healing system in anything. Like, my laptop may crash because power went out, right? There is no way I can build a self-healing system that this PowerPoint presentation will keep running unless I fix the global power problem, right? So it's not about, it's really that path towards building something self-healing and then defining your goals. Because the goal may be, Mark should never see that incorrect number. It's okay for him to see it a day late, but I don't want to show him a number which is incorrect. So there we can actually now start to say, look, I am willing to take that trade-off where I have many more checks on the data to the extent that even a human being looks at it before it's actually shown. But then you're trading off the latency for like your correctness, right? So it's again, I completely agree, and having like the research that eventually led to Unravel, our first goal was we wanted to build a self-tuning Hadoop. And being in academia, we could actually work on these things. And what we learned from that entire journey is that nobody was actually like saying, if you can't build a self-tuning Hadoop, the entire project is a failure. That's when we started realizing even things are not even people who are working with Hadoop, this is back in the day, like 10 years back, right? They don't even know what happened. So we started thinking, okay, like instead of trying to build a self-tuning Hadoop, let's try to make all of this data easier to consume. So slowly a lot of these thoughts originated, and if we hadn't started with that ambitious goal, we probably would not have even built some of these pieces that make life easier. So in a nutshell, yes, it's extremely hard to build something that will auto-correct correctness problems. Because even correctness is in the mind of like somebody, and they may not be able to articulate it, right? But that journey towards getting that, you'll build something which is useful, such that at the end of the day, we are trying to make teams efficient. So if you can save 5 steps from what they have to do, overall productivity is increased. So that's another way of thinking about these problems.
Hi, Shivanath.
Yes.
Thanks a lot for wonderful talk. I just want to ask you, do you use any proactive based algorithms for making this solution possible as well, so that it can give you the right kind of results that we are looking for?
Yes, so if I understood the question correctly, the essence of the question is, can we be more predictive so that some of these problems can be predicted early and then even corrected, right? Is that the essence of the question? You use the word proactive, right? Yes. So proactive algorithms often end up being these algorithms that can predict and forecast and things like that, right? So once again, my suggestion, having worked on many of these things, is to, you should basically think about always think of the use case first. Never think of the algorithms first. Right? Start thinking about the use case. What's the use case? I need to predict the cost of a query before it starts running, because if it runs and eats up that cost, the cloud vendor is not giving me back. Then I need to be predictive, right? Or if I get an alert that this pipeline will miss its SLA, halfway at least in the pipeline execution, then my team can jump in and solve the problem, right? They're both predictive problems, but one is much harder because you have not seen anything about that query. In the other one, you have seen how the pipeline runs, you can compare with the baseline. So if you start with the use case, then next is start thinking about what data do you have to even address those. Once you have the use case and the understanding of data, then start thinking about algorithms, because there's been so much innovation in the algorithm space. Like back in the day when I was working on this, it was random forest and support vector machines, right? Now it's deep learning, and like a lot of innovations happened. So yes, there are algorithms, but work, use case, and then data, and then algorithms. I'm happy to deep dive into these things. It's a very loaded question, and there are many dimensions of it. Thanks for asking it, by the way.
Hi, Shivnath, thank you. So, like we had many systems. Now we brought one more system. So for other system, observability, we brought this one. Now for this system, again, we need to build a observability.
Yes.
So is there like anything you can suggest, like, because it's keep on going. And when this system is down, how the other things again started coming, like performance or other things?
Yes, yes. Fantastic question, right? Again, the Heisenberg principle, right? You add one more thing and then things become, like, how do you manage that, right? So this is where, think about that self-healing. This system need not exist outside. What is the system? It's actually intelligence, right? You could merge that along with your larger system so it doesn't seem like an external thing. And this is what has happened in control theory, right? You could have multiple components that are all auto-healing and things like that, but something needs to connect and correlate them together so that overall the entire system is auto-healing. So there are very interesting things to be learned from control theory that can be applied to that problem, but it's a very genuine problem. You bring another system, then who is watching the watcher? Yeah. Yes.
Unravel's vision for data drifts and model drifts? Like, I wanted to know because you talked a lot on SLI, SLAs.
Yeah.
So, because towards the end of the day, it's just the business logic which just keeps changing here and there. Of course, people talked about malicious SQL codes because I literally feel there's a lot of things that change in the database schema every time we think something new. So what's the Unravel's vision towards SLI and SLOs in terms of your data drifts and model drifts which are happening in the business logic today?
Yeah. Our vision is we want to work on it and solve it. Right? It's a hard problem. So what the gentleman asked is like, this concept of like, model drifts, data drifts, like you build a machine learning model and every model is built based on a certain data distributions, properties and things like that, right? What if the data properties change? Your model now is incorrect. Who's detecting that? Who's fixing that? Very genuine and important problem. It's not like that is, we have a generic answer for that. There's a lot of research also happening. But what we feel is, it's like, at least we should stop thinking of that as an isolated problem, because often it is part of a larger data pipeline, and maybe the drift, like you can't fix a model, but you can detect early that this distribution is changing, so later things need to be checked. Yeah. So at least detect them early. So look at that spectrum of like how like we were suggesting, right? Work on detection, and there is great algorithms that are doing data drift detection and prediction, like changes in that. So start with that, and then as you learn more about it, see if we can make things more, we can build a self-healing nature into the model itself, so it retrains dynamically, which is easy to say but hard to do. Yeah. Right? How are you getting, like, it's a new data representative then. So once again, no easy answer, but this is one of the reasons why we are having a conference like this, right? Let's bring the best minds. Sure. Make them aware of these problems, right? So that we can actually get a collective brain power of an entire community to work on them.
Sure, like my next question, just a quick round of question, because people want to move towards that stream layer processing, right? Everybody wants ultra real time inferences and things like that. So like there are a lot of downtimes which people face when they just migrate towards that service to another. So what's your view upon like how should they approach that kind of a problem statement when they're trying to migrate from an static batch processing to an real-time stream processing? So how should they try architecting it? Yeah. Like with respect to all the matrices that you're talking with respect to Unravel.
So again, I have only one rule of thumb which I've learned the hard way, but now that like at least I try to apply is always understand the use case. Understand really well. Don't get carried away by technology. There's Spark streaming, and now there's Flink, and there is the next great streaming engine. Let's use it. I built a streaming engine myself for my PhD back in the day, right? It's easy to get carried with technology and then go the other way. I'll take some technology, throw it to some data, and something will happen. Most of the time, that result will either be wrong, it will be too slow, or the project will entirely fail. It should come the other way. What's the use case? Does that use case need the solution? If so, then how do we make it, how do you make it to work? Pick the right technologies, and maybe you have to innovate. So it's like no silver bullet, I wish I had. But again, based on our own experiences, it's use case, technology, data, then algorithms and architecture and things like that. But of course, you have to go back and forth between them. Yes.
One last question from here.
Hi, myself Neetu. So I'm part of a Dataops team. So each and everyone's data will be completely different. So the data observability also will be different for everyone. It's like how Unravel going to handle that? Are we going to give them some common matrices, or there is a possibility of customizations which can be go deep level of this observable?
Great question, Nidu. Like, one thing I just want to make it very clear is I hear a lot of how Unravel is going to do it. Unravel will do something about it, which is interesting, which we love to share with the community. It's all about how are we really going to solve these problems. So the question that Nidu asked is like, data is different for everyone. Can data ops or data observability be the same for everyone? So interestingly enough, the problems, like the focus of a lot of these things is what are the problems? Like we just discussed about the problem of data drift. That's a generic problem. it's not specific to the data, but maybe specific to the domain. In a certain domain, this may be much more common than certain other domains. So it's, I would say once again, it's, this industry is, in some sense, it's in infancy. It's starting and people are trying to think about these. We are trying to gather the common set of questions. And what we are seeing is there's a lot of commonality in the questions. What people are looking to do, they're looking to solve, where they're challenged, right? And can we convert that into a common set of solutions? That is the real challenge to be solved. So again, happy to have deeper conversation, but it's a great question. Thanks for asking.
All
Okay,
right.
so everyone is telling me that time's up from multiple angles. So once again, thanks a lot. Really enjoyed this talk and enjoying talking for a live audience after a long time. Thank you.
Can we hear a round of applause for Shivnath Babu? He's going to be available for you guys to network. Once again, just a gentle reminder, this is a networking, collaborative, and a learning conference, right? So, guys, good news. We're going to take a small break, all right? But in the meantime, if you're capturing any photos or anything, I just got the update that we're not just going to have prizes for quiz, but we're going to also have prizes for your social media interaction, and it's going to be specific to LinkedIn, all right? So you all can put out a post, and I strongly believe social media is a tool even in the space for professionals, right? So take up this opportunity, and as a consequence, you could probably win some cool gadgets, right? So the hashtags that you're going to be using are hashtag DataGeek, hashtag DataOps, hashtag Dataops Observability, and most importantly, tag at Unravel Data. Cool? So put up your LinkedIn posts and let's see who wins it at the end of the day. Cool? Are you guys excited? And if I point at you, you guys go? Lovely. Thanks for remembering that as well. Once again, that was Shivnath Babu. Can we hear a round of applause? You all can get up, stretch your legs, go to the beautiful lawn area that's available right here at the Orchid Hotel, Domlur. And we'll move forward with the next agenda. So you'll have a 15-minute break. So when you hear my voice coming in from inside the conference hall, please respect that and make your way here. There's also food available where you can eat the amazing team The restrooms are, once you exit, the restrooms available for you to freshen up.
starts with the but as you keep moving faster. So this time, let me try with a few more sounds. One of my favorite sounds is the water dropping like this. Super cool, right? There's no effects on the mic. Right, and
still see a lot of people outside. If there was anything, it would just just guys, get it. Yeah, sit there. Thank you. Yes. Feeling that energy out there. How many of you guys have made friends? You've met someone new and said hello, and you're real fans. Oh, wow. You guys are really here to network. I love this. How many of you guys got the opportunity to meet the Unravel team? Awesome. I hope all of your doubts are cleared. Yes, any questions? Any pending questions? Anybody from? All right, that's awesome. You guys have done an effective job by clarifying everyone's queries so far. All right, I see a few more people out there. I think we are filled at 70%. So can we move forward to the next speaker? Yes? All right, just before that, I'd also like to understand how many of you guys have started with the LinkedIn posts. Okay, now this is getting competitive. Trust me, guys, the gadgets are super cool. Also, this gentleman right here learned how to post on LinkedIn. So great work. Thank you so much. So are you guys ready? And when I point at you, what happens? Little dull that was. Okay, let's try that again. When I point at you, what happened, guys? That was coffee only, you know. How are you all sleepy after that? Come on, let's get a much, much better. Okay, so the agenda had changed a bit. We had another speaker who unfortunately had some personal issues. So so sorry. Yeah, we have our current speaker who moved his time slot up on short notice. So can we hear a big round of applause for Mr. Anuj Gupta? Just before I bring him on stage, I'd like to say a few words about him. All right. All right, so Anuj Gupta is a Chief Artificial Intelligence Officer. How cool is that? Yes? Yeah. No, I'm still pointing. Yes, all right. So Anuj Gupta is a seasoned executive having led artificial intelligence efforts at both startups and Fortune 50. This includes Airboot, Freshworks, Hawaii, Intuit to name a few. Currently, he is the Chief AI Officer at Vahan Incorporations. He's also authored a major book in artificial intelligence in 2020, guys. Come on. Right? So I'm sure, Mr. Anuj, you'd like to also introduce yourself and let others know what other accomplishments you have. And I'm really curious to. All right, he's a man of few words, but he has a lot to speak in his upcoming session. So please, guys, give a round, warm applause for Mr. Anuj.
Thank you so much for coming today, and thanks a lot for the Unravel team for inviting me for this talk. What I'll be talking today is about AI and data observability. In my humble opinion, this is one particular sub area that's going to boom a lot, especially in next 1 to 3 years, right? And so what I'll be talking basically is two aspects. One, how is data observability very, very important to AI? And the other side of the picture as well, whereby how AI can really help data observability help achieve its objectives. Feel free to stop me anywhere, any questions, don't hold them till the end. I will love this to be super, super interactive rather than one way. So, bit about me. I have had a chance of working on AI for quite some time now, long back in the days when it wasn't the fad that it is today. And one of the things that I realized very early in my journey was the way you do AI in academia and research labs is very, very different when you're part of product teams. And this whole journey actually led me to write a book along with a couple of other folks. We were extremely fortunate that the book has gone on to do fairly well. The book is about a perspective of AI from trenches, and data plays a very, very, very crucial role in it. and how that ties to AI or data observability is what I'm going to be focusing on. How many of you have seen, and a lot of this has happened in last 10 days, that's it. So on the left, what you see is a system from Meta whereby you give a prompt and it will start generating videos for you, right? What you see on the right is a company by the name Synthesia. This is picked to be one of the fastest unicorn to come out of the European region. I think around 3 odd years and they should be hitting the unicorn status. I think this happened yesterday morning, whereby there was a podcast that was between Joe Rogan and Steve Jobs. We all know Steve Jobs is no more in the world, but this was generated by AI. The key point that I want to drive is that whatever I have seen across industries, across companies, most teams are actually struggling to realize the promise of AI. This basically could mean only two things. One, either the ROI that is promised is not there at all and it's an hype, or there is certain aspects of which people have not talked enough to understand how can AI really be leveraged. In my humble opinion, the hype is not an hype. The ROI is very much real. And these are some of the examples just to illustrate that point. By the way, how many of you have been part of AI teams where you have actually taken data, built models, deployed? Okay. I think a lot of you come from the world where you part of the data teams, more involved in building those data systems, ensuring that the data is available. The companies have the petabytes of the data that they are after, right? I, on the other hand, with my teams, often assume that the data is there, and then my journey starts, right? Sorry, I think I went a little too far. And it is because of this promise, this graph, I'm sure all of us have seen, we all will continue to see. The point being, be it be countries or be it be organizations, you'll see more and more money being pumped into AI because of the promise it holds. We all need to understand this, that no one is after data. What they are after is the value that the data can provide to them. And that is what is driving this frenzy or this rush of trying to do AI. Now, most people think AI means you take a data, you build a model, and you are doing AI. In my humble opinion, that is not the case, and I'll come to that point. Right? Despite all this funding, this euphoria that is there, from where I have seen two sides of the picture. One is most startups and MNCs who are new to this paradigm, where most projects don't move any business needle. For me, a successful AI project is not where you have built a model. For me, a successful AI project is where you have contributed to the P&L or you have helped company create a disproportionate advantage in the market via the product or features, right? So building a model is just one part of the whole story, right? Most AI systems in most organizations still today continues to be very basic models, logistic regression, decision trees, XGBoost, blah, blah. You look at the PR coming from these organizations, it will talk of this cutting edge AI, right? I have often not seen either the edge or the cutting side of the edge in most of these organizations. Most early AI teams seldom produce the ROI for the business, right? In most cases, what happens is the bridges are burnt on the both sides. Business feels AI is a fad. The AI team feels that the business or the organization does not understand the various nuances that it takes to successfully build AI systems. Most organizations do big data. You talk to anybody in the company, they'll say they have petabytes of data, but they seldom have the data for the AI problem at hand. This is also a very realistic other side of the coin. On the other hand, there are a select few which are doing very, very different in the same space. Most projects move business needle. There's big ROI. The business and the AI teams absolutely love each other. there are newer and newer pioneering systems that are coming out which help create this disproportionate product advantage, right? Look at the captions in YouTube. Before that, it wasn't there. It was purely dependent on the content creator to provide, which they seldom used to do. Look at Spotify's recommendation lift. The entire space of recommendation engines became popular because every Monday morning Spotify would know what it should dish to you that you will love to listen, right? Tesla self-driving, Gmail's autocomplete, they use deep learning big time to build these systems, and their reality often matches the PR. Most AI teams produce significant ROIs. There is a lot of emphasis on data collection, right? They often have well-curated, large data sets for the problem at hand. So there is one side which is struggling to realize the promise of AI. Yeah. So by curated data, I typically mean is being able to create a data set for the machine learning problem at hand. In machine learning, a key step is always about understanding the problem statement and then looking at your entire data flow to find, do you have relevant data for the problem at hand? And from there, creating those blocks of data and taking one particular block, which you call as the training set, right? I'm talking of that in particular, right? So the, the, the main question is, why is AI success limited to very few? Or what is that these big guns are doing so very well and the others are not doing? The answer is not simple. The answer is fairly complex. And I call it AI maturity. There is, at the intersection of technology, processes, and people, you need to fix a lot of things. It's not just about taking a data set, training a model, you're not doing an AI, right? And that's when the AI magic happens. It is not possible in the interest of time to go over all of this. This almost requires a couple of hours of session, but what I'll be focusing on is just one aspect which is under the umbrella of technology. I'll take a quick pause. Any questions so far? Is everybody with me? A big yes? Yes. Great. If you read popular media articles, often also the articles coming out of the big techs, what is often sold is that you are doing a AI if you have a good model. And what is a good model? It has to be a state-of-the-art algorithm, right? It is something that is beating the known benchmarks. While this is indeed the case for research labs, for academia, this is not the case for industry. In industry, if you can build a model which can solve your problem to a decent extent, you have moved very, very far. In reality, in my understanding and my experience, good AI in industry essentially comes down to these 4 points, and if you have done the 4, you've actually conquered 80 to 90% of the battle. Modeling and understanding the business problem statement and modeling it correctly. Understanding, is it even an AI problem? Do you even need AI in the first place? Or if a bunch of regexes can do the job, absolutely that's far, far better than building a complex AI system, in my humble opinion, right? Defining the right metrics. And when I say metrics, I mean 2 things. One, of course, machine learning metrics, so that you can monitor and understand how well your model is. Second, defining the right business metrics, because at the end of the day, you are building this model to move some needle for the business, and your business metrics must be able to talk to ML metrics and vice versa. What generally happens in most cases is you build a model, you have great ML metrics, 95% precision recall, everything great. You go into a production, you actually end up with a very, very, very different numbers, right? And the numbers business cares about is not these precision recall, AUC, ROC, and all of that stuff. These are vanity metrics for your thing. They are necessary, but not sufficient. And if you can build a correct and a comprehensive data set, right? What do I mean by correct? Is that data does not have errors, label does not have errors, And by comprehensive, I mean a data set whereby it is very close to the kind of data the model is likely to see in the production. So the universe in the training is very similar to the universe that it's going to see in the production. Often 80 to 90% of the battle is won. Even if you can get this far, apply a simple logistic regression, it can take you very, very far. This is very different from how, in my opinion, AI is often projected, which talks of these crazy deep learning models, which are, if you look at this large language models and that entire realm, that's a very different pursuit. It's about trying to understand what AI can reach to in its limit, understand what is even possible, then come to the question of feasibility, and then come to the question of optimality. That's how typically science journey progresses, right? So it's a slightly different story. If you see in this 80 to 90% that I've talked of, there is no mention of model at all. Right? Building a model is just a small part of the remaining 10% for most projects in the industry. And this is an experiment that you should actually go and do. Take a problem statement, take little data, it may be dirty, try and apply all kind of algorithmic techniques, the most recent ones, look at those results, and in parallel create another team whose only job is to create a comprehensive data set, a good high quality data set, and then apply a very simple algorithm on it. In most cases, you will see that the later will do better, and I often call it data beats model. If you have built a good comprehensive data set, a large part of the battle is there. And AI thrives on high quality, trustworthy data, right? And there is a nuance here, and I'll come to that. Sorry, right? We all have heard of this thing for many, many years now. Data is the new oil, data is the new oil, data is the new oil. We all understand this. I think it has been used so much so that we have actually forgotten a very fundamental aspect of this. What you actually pull out is a crude oil. What people are looking for are these models that can do really jazzy things that will amaze people. This is almost like building a supersonic jet. Try and ask anybody, can you fly supersonic jets on crude oil? Ever tried this? You can't even move your scooter or a bike, forget about a supersonic jet. And this is something a lot of teams actually miss it. You need to set up the refinery in your organization. There is no way anybody can take crude oil and create value out of it. It doesn't happen even in that world. You need to set up a refinery that can take this crude oil, take out various components out of it. Sorry. Each component must have a quality SLA. This is how all refineries also work in the world. I have still not understood why this is not the case with data refineries, right? The quality and the trustworthiness comes from here. It is from this process of data engineering, what each of you do, right? That the quality of the data and the trustworthiness of the data comes from. And what does it mean? It means you ingest clean process data, right? Consumers should not worry about from where it is coming, the time frame, the process, right? You monitor data quality very carefully, and then you give it to your consumers. This could be analytics system, this could be data analysts, this could be downstream data products, this could be AI team, right? And this is one of those things that, in my opinion, big tech firms have known for many, many years. As a matter of fact, one example I'll give, I think 2015, YouTube moved its recommendation algorithm from a basic statistical machine learning to a deep learning model. There was a team that was created 4 years before this model came into production, whose whole job was to create a data set. This data set is called 8M. It has 8 million hours of videos that they collected. There is a paper available on the web. You guys can go and read. And that's the kind of effort one has to put in data to be able to see the kind of magic that one often asks for, right? And this is where I believe data observability plays a very, very, very crucial piece, right? And data observability, in my experience, is a specialized field that requires data engineers and this whole notion of full stack data scientists that can do everything end to end. While it is great to have, there are too many complexities for one person to be able to handle all of this, right? We all have known this thing. This is another fact that has been there for last 10, 20 odd years. But there's a underlying aspect here, right? Most data stores that are there in organization, it is not the case that they are completely garbage. So this picture is slightly misleading because there is no complete garbage that goes in, right? And there is no complete garbage that comes out. What actually happens is that the amount of noise might be only 2 to 5 to 10%. Somehow it is often assumed that the impact this noise will have on your AI systems will actually be linear. So if there is 2% noise, the model might be off by 2% or 5%. It is never the case. At least in my understanding, there are no simple mathematics, at least that exists, that has a relation between data quality and the model performance. Right? These are fairly complex equations that have a lot of underlying assumptions, but this one-to-one mapping surely does not see. And this is something you guys should go and try this, right? Take a simple data set of cat versus dog, try and introduce error in the labels of the data, keep training models on different variants of this data, and observe yourself how the model performance degrades. As a matter of fact, we actually published a paper last year whereby we show that if you take more state-of-the-art models in NLP, and if you start introducing errors in data, right? So toy might be spelled F-T-Y rather than T-O-Y, something as simple as that. If you start getting to a point whereby noise in the data is anywhere between 10 to 15%, we saw a degradation of almost 50% in the performance of these models. Okay? And this is something most AI teams are aware of. So when they take a data store, dig deep, right, takes that petabyte of data that the company is sitting in with, dig deep, they actually end up with a very small data set that can actually is worthy enough of being used, right? And that's what I meant by having petabytes of data, but seldom have the data set for the problem. So this is one side of the picture, right? And then there is the other side of the picture, which is how do you use AI for data observability itself? We have already heard a lot about what Unravel and other tools in the market can do, and this is on very similar lines, right? The essence is why in today's world you have to wait and see for something to fail and then react, right? Why can't you build systems that can look at this data and flag issues when they are about to happen, right? There is one more aspect in the data, and this is something I have often seen, is that when you go and ask the product team, hey, for this feature, what amount of data is there, they will tell you we have last 3 years of data. What they don't tell you is that over last 3 years, there were 100 different fixes that were made to the product. So your data is not a homogeneous collection. It is actually how soil amalgamates in life. So if you keep digging in earth, you see different layers of soil. You can actually see different layers in the data where each layer corresponds to the change. Now imagine there was a change that was made 2 years ago, which had a bug, which corrupted that data. You have actually lost that entire layer because now there is no way you can go back in time and fix all of that. So another very important aspect is that the fixes in the data must be made then and there. If you don't do in that day or that week, it is highly unlikely it's going to happen anytime later. And this will have repercussions when you start to build your AI teams, you start to bring that talent, which is often extremely tough to find and extremely expensive as well, right? And they come and tell you, hey, you are actually sitting not on a gold mine, but a bunch of ash pots. And this is something I have seen in a lot of large organizations very often. The idea being, can you use AI to identify what is likely to go wrong? This will help the individual, and I'm not a fan of AI being as artificial intelligence, as the idea of replacing humans. I personally believe AI means augmented intelligence, at least in today's world, right? So this is more like those superhuman movies whereby there is an individual, fairly normal, there is this armored suit, he actually wears that and has these magical powers, right? You let your team, rather than figuring out where is the issue, why the issue is there, on actually fixing that issue, because that is a very hard problem. Fixing issue is not something that systems can do as of today. But they are fairly good enough to understand where the issues might lie, right? Help optimize, right? You will love to save even before you burn. Once you are burnt, anyways, we're going to save, right? And this matters a lot, right? I think try and go back to your companies and see the kind of bills AI teams might have generated when they first came in for first 6 months and tried to use state-of-the-art algorithms, which actually will lead to $1 million bills on the AWS because the GPUs come extremely, extremely expensive, right? How can you make systems more efficient, adhere to SLAs, and given the complexity, right, it is not possible just for humans to be able to figure out all of this stuff. So the whole idea being be proactive rather than reactive, and at least what I have seen of a couple of organizations in last 1 to 3 years, you'll see that AI and data observability will now become a very, very fast-growing area in next 1 to 3 years. There is Unravel, there is Monte Carlo. Some of these companies have come up extremely, extremely fast because people have started to realize, right, data is indeed the new oil, but you can't feed that data to your AI systems. Cool. I'll take a pause. Any questions? Sure. Sorry. I think they'll bring the mic.
Hello, Anuj. Great talk. I think you hit the nail on the coffin, as I said, when you said that a rich data set is what is. I mean, your AI is as good as the data itself. But therein lies the problem, right? How do data science teams, or for that matter, data teams, know that we have the right data? Because the understanding of data is truly with the product teams, right? And so when the data comes to the downstream teams like data science and data engineering teams, yes, they can check for basic things like nulls and, you know, some of those sanity checks, as we call them, you know, take out the test accounts and all of that. But they won't be able to kind of say that there is a bias in the data, for example, or, you know, the data is not the right data. How have the organization solved that problem in the places it has been solved? Because that is exactly the problem that most of the organizations are trying to solve for.
So the only answer to that I have found is that you need to start AI early, right? Whenever you will bring in the team, the first few months are going to be heated battles, because that is when you're going to discover that what you thought is a great data that you were sitting with, it is actually not. And that is when those fixes will start to go in. The problem that happens is that in most organizations or most CXOs, when they bring in AI team, they believe that the magic is going to happen tomorrow, right? So I have not had a time, but the ROI curve, actually what executives expect is this, where it will start initially some hiccups and then it will just take off. It doesn't work that way. The ROI curve in AI systems work very differently. One hack that I have found very useful is that senior product leaders should bring a couple of data scientists as interns every year. Let them work with that data. That's a quick and a cheaper strategy of calling out those gaps much, much earlier. Second, there is also another aspect, which is I don't know upfront what data will be useful, right? My advice to all product managers is when it comes to data collection, be extremely greedy. Collect whatever you can, however you can, how much you can. Because that's one process, no matter what you do, you cannot short circuit the time that it takes to collect a good data set. You can hire the best in class, you can build the best infra, you can do whatever you want to do in the world. You cannot shorten or speeden up that process. If it takes 2 years, it takes 2 years. And you'll see all big tech companies are after data, they are not after anything else. Right? So Google has Vision API not to democratize AI, in my humble opinion. It is actually to use your data to strengthen their models further, so then they can do the kind of projects they want to do for the DARPAs and the DRDOs and others. Right? And that's where lies the problem, whereby people are not willing to let their data stay on the cloud and sign those agreements that my data will be deleted, and that's where they brought federated learning. I don't need your data. Once I have seen a snapshot of it, I am just interested in the learnings from the data. I have already taken that out. Even if you move, I have already gained whatever I had to gain. So when it comes to data, you have to be extremely greedy, and you have to start investing early in terms of trying to use that data. That's when you will really understand and uncover all of those things.
Thank you, sir. So what about strategizing standardization? Because if you see bigger teams, there are TensorFlow developers, PyTorch developers, but at the end of the day, it's a model noise that we are adding once we go to the fusion. So there also models, the software engineering problem, right? You know, it's still a software engineering problem that still prevails. But how about strategizing a standardization in the entire operation going to impact my production, like in your experience, like?
So two things. One, when you say standardization of the machine learning frameworks, there's already fair amount of work that is going on, and in my humble opinion, that's not the big problem, right? If you look at the deep learning, right, it is the standardization of the data quality, right? And you have to also understand this is part of the product teams. Product teams work with two things. The moment you bring in anybody, the first thing that is told to this person on day one is try and get some early wins. The second thing that will always be told to you is perfection is the enemy of good, which is great because you are still trying to figure out a product, what is the product market fit, right? Is it going to work and all of that, right? And in that hustle to kind of move very, very fast, there will be casualties. Data is often the biggest casualty, right? Data is often, no matter what most companies talk of, data gets the most faster treatment that I've seen in most organizations, while everybody says this is what is gonna get us the maximum amount of value. Yeah. So it's not just about the scale part that I'm talking here, right? What I'm talking about the quality of it. What you collect good enough, well enough, so it almost anybody can take the data and recreate how things would have happened in reality, or replay the past 6 weeks or 6 months or 6 years, whatever is the amount of data that you have.
Yeah. You, in the end, you said about AI you are using with maybe that AI engineering in the data observability concept, right? My question is like we had already big data, we had already let's say data analytics. There also they use AI, right? AI engineering, most of the places we use it in the industry. So how my let's say three perspective, right? AI engineering in big data, AI engineering in data analytics, and AI engineering with data observability. With this perspective, what's your which one is more what can I say, which is more robust as well as outcomes? With respect of ROI, initially we started with ROI, right? So with that way, we need to think about ROI. So which is the more out of the three different infrastructure we can say?
So I am not sure if I've understood the question correctly, but one of the pieces that you mentioned is that we've been using AI in big data. We have used AI in analytics.
Yes.
We have used AI in data observability, which is a better or more robust.
Right.
If that would. So, I mean, to me, this is not an apples to apples comparison, right? You don't have a choice. The point I'm trying to make here is that you'll have to have good data, and the way data stack works is you have data engineering. On top of it, you have analytics. On top of it, you have what is called as predictive analytics. And on top of it, you have the analytical models, the churn propensity and others. And then you start working at things which are working with text, images, speech, and that kind of a thing, right? So the AI, right? I mean, these are little abused or misused words, but that's how the stack generally is. The idea is that the quality at the top is a function of quality at every step in this process. So you have no options. You will have to have high quality stuff at each of them. So you need, AI is just a tool to help you get higher data quality in big data. It is not the case that AI is a magic wand, it's going to solve all the problems. It is just another line of attack to a bunch of problems. A lot of these problems earlier were very hard to solve. No known engineering technique have good answers there. Here is a technique that seems to give you a decent answers at some of these problems. All AI models are wrong, just that some of them are more useful than the others. I think that's the right way to think of this.
Okay, can I use this observability concept in the big data analytics as well as
Observability is all about, there is a lot of things that are happening on the ground. What you want to make sure is that things remain high quality. So how do I systematically observe and act rather than just react? So if you look at it in this abstraction, it is not some sanctosanct principle that has come from heaven.
Okay, thank you.
Yeah, hi. All right, that concludes our time availability for the Q&A session, but most definitely Anuj will be available in the lobby, so I'm sorry we couldn't take your questions at the moment, but most definitely you can reconnect with him, and I think he'll be more than happy to meet and discuss the same, right? Can we hear a big, big, big round of applause for Anuj Gupta right here? Thank you so much for taking the time and addressing this audience. All right, everyone, how are you guys doing? Great. A lot of learning happening here. Yes. So when I point at you, you go. All right, perfect. All right, so up next on the agenda, we have a panel discussion. Are you guys excited for that? All right, just give me a moment. So, all right, so the topic for the panel discussion is going to be Dataops Observability, and the theme is old wine in a new bottle or the next big thing. All right. So the panel host will be Shivnath. Babu, say hi. Yeah, some more energy there. Hi, Shivnath. Look at them. They're so lovely. They're saying hi to you in the sweetest way possible. All right. So joining him on the panel, we've got, I need you guys to like clap. So we've got to hype the speakers, right? All right. So joining Shivnath on the panel, the first panelist is Govinda Sambamurthy. Hi. Yo. Look at this handsome gentleman coming up. He's the head of engineering at Enterprise Data Probability at Atlassian, right? So he is an author, innovation champion, and software development leader. Govinda is currently working as head of engineering at Atlassian with nearly 2 decades of distinguished experience developing and delivering products across technologies and verticals. Throughout his career, he has been recognized as an innovator, leading technologist, and an absolute team player. Govinda is very passionate about execution, excellence, and customer-driven innovation. His current role, he is bootstrapping an engineering team in our very own Bengaluru city. So can we hear it once again for Govinda? Joining them on the panel is Akila Prabhakaran. Guys, put your round of applause for the first lady taking up the stage in our conference here. So she is a consultant data scientist working with Dell Technologies. All right. A little bit about her, data and software product architect with over 22 years of experience. So she's a real veteran in the game of data science. Thank you for your accomplishments, ma'am. So she's diverse in different business verticals as well as academia, designing and developing business intelligence solutions and insights for planning and process improvement from complex heterogeneous data sources. Once again, thank you guys. Joining them next on the panel is Chandrasekhar. Hi, sir. Welcome on to the stage. He's the head of solution engineering at Infosys. So let's hear it for that. A little bit about him. He's experienced in architecting and implementing solutions in the data and analytics space, extensive experience in executing large projects for financial services, energy, utilities, communication, and media clients across US, Europe, Asia Pacific, and he's experienced in architecture consulting involving future state roadmap definition, use case identification, and business value articulation. So he is definitely an all-rounder. Thank you so much for joining this stage with us. Next up, joining them, the final panelist is Giriraj Bagri. Let's hear it. He definitely brings a very unique energy in the presence of us. So Mr. Giriraj works with Unravel. A little bit about him, he is the VP and Engineering Operations, and he is well versed with data and AI platforms. That's right. He's into big data and e-commerce leader with extensive experience in learning engineering and operation teams for SaaS and online market platforms. The breadth of his experience includes managing big data platforms, data ops, database engineering, SRE, automation team in on-prem and multi-cloud technologies. He's super passionate, and it's going to be an amazing lineup of panelists. Can we hear it one more time for everyone that is here on stage? Again, driving the panel is going to be none other than Shivnath.
Thank you. So really looking forward to this panel with a lot of illustrious panelists. So actually, we'll just first have a set of questions that I've actually prepped up based on some of the things that I've actually learned, even like listening in to some of these talks today. It was a great talk by Anuj as well. So then we'll open it up towards the end for questions from the audience to the panelists. My very first question to the each panelist, we'll just go down. In fact, we'll get the lady the first chance always. My first question is actually going to be first, please say a few words about yourself as well as your experience. And the first question is going to be, what in your journey, in the things that you've seen in your career, what are some of the challenges you think observability can solve? So once again, a few words about yourself so the audience has some context. And then please use your experience to tell everyone about some challenges you feel observability can solve.
Thank you, Shivnath. Honored to be here. And I will, I think I was given a good brief here, but just to give a background, I started my career with Infosys. I have a degree from IIT Kanpur, started my career with Infosys, was with them building product solutions for credit card companies and data warehouses and warehouses in general. After that, I moved on to build the entire office automation stack for IIT Kanpur, automating their payroll and employee resource management and all other aspects. Then moved on into travel technology. I spent over 14 years in travel technology building end-to-end solutions for cruise clients, corporate clients, end-to-end booking systems, backends for Expedia, Orbitz, all kinds of stuff. And then moved on to building AI solutions for the Power Corporation Corporation of Karnataka as part of a consultation project with National Institute of Advanced Studies. And I spent a good 5.5 years after that in the Supercomputer Center at ISC, where I was a consultant building the same observability stack for them for their HPC systems. And they had the state-of-the-art Cray, then Cray, now HPE XC40 machine, which was one of the top 500 supercomputers in the world. It is a petaflop machine with 33,000 cores, massively parallel machine, which was primarily used for research and addressing the question of observability with that project in context. So this massive 33,000 core machine was one of the workhorses for the supercomputing center. They had a lot of other small scale clusters and the DGX system for AI and deep learning too. But the key challenge there was we have a few hundred researchers submitting bad jobs on the system, and this is a system which is heavily reliant on infrastructure. The water cooling is critical to the system, power is critical to the system, the temperature and pressure of the water is also critical to the system here. And even though Cray had, or HPE had built-in resiliency, recovery and all of that, they had a proprietary interconnect also for this massively parallel system. But how do you observe, are my jobs going through on time? The center had a fair share policy, but the users are never happy, right? They want to understand, why is my job waiting in queue for such a long time? Why are the other jobs going through? Can you change the scheduling policy? Can we build in some kind of dynamic capacity planning? How much of the system or resources are we utilizing? What kind of, with cloud, will it make sense to push some of these HPC jobs on the cloud? Will I get results on time? So the entire stack was built from scratch using logs and all of that. And that helped overcome all these challenges. One, capacity planning, being able to monitor resource utilization, being able to open up these resources for others, being able to proactively suggest if a particular job is going to fail, and maybe alerting the user upfront, monitoring those temperature and pressure changes regularly, and alerting people who are responsible for system maintenance. So a whole lot of that stuff was possible only by building that observability stack bottom up. And again, these days when we are talking about systems, it's not just monolithic applications running on single database servers. We have legacy systems, we have databases, data warehouse, lakehouse, and a lot of interconnected systems where data is in those batch processes. You just can't do away with batch processes, right? You need those overnight runs. And then you have those streaming processes, and then you have those real-time AI analytics. And how do you basically observe the entire data pipeline? And the underlying data pipeline is extremely complex, a lot of workflow orchestration too. So something going wrong somewhere upstream can impact a real-time decision that a drone takes, or another, your AI system takes somewhere which is very mission critical. And without having a basic observability stack, it is hard to, I think, iterate quickly, hard to manage change, and all those other challenges that Shivnath had mentioned in the morning.
Thanks, Akhila. In fact, next I would actually love, Chandra, you work with a lot of customers, right? But before that, I can totally relate to what Akhila actually talked about. Because before the Cray and before the HPE, the Supercomputer Research Center in ISC, right here in Bangalore, right, had a IBM SP2 machine, which was one of the two supercomputers in India at that time. And the other one was at CDAC, the Param one. And I worked on that as an intern while I was doing this thing. And I remember there was it was message passing interfaces, something would fail, and you had no idea what went wrong. So I can totally relate to that, and thanks for building all of that. So Chandra, you actually work with a lot of customers. Yeah. Would love to hear your side of anything you have learned.
Yeah, I think I relate to a lot of what Shiv, you said, Anuj said, and we just heard right now, right? So one of the things that we see as a challenge in observability, there are a lot of monitoring tools, like one of the gentlemen asked, what is different between monitoring, observability? A lot of tools out there, but what we feel the biggest challenge we see with the customers is the enterprise context. How do I relate what I see as part of these monitoring tools to the enterprise context? If I take a simple example of, let's say, SLA, am I going to meet an SLA is not just a factor of is the job running on time or is it going to finish in 1 hour. If my SLA is 2 hours, even if it is taking 1 hour 30 minutes, it's still not a problem for me. Right? That information is something that has to be curated from the enterprise, where a lot of places the challenge is actually for us to get the ways of working changed in the enterprise where this kind of information is actually captured. A lot of times data quality related problems are also related to, am I actually having the right business rules? Am I actually having the right kind of exception management process in place? So the challenge around observability we also see in terms of getting the enterprise context. The second major challenge that we see is in terms of cost. With a lot of movement onto cloud, everything that you do, every mistake you do is resulting in an incremental cost. In the on-prem days, you got the servers, you just depreciating those, you don't really spend more on it. But today, if you have to rerun a pipeline because there is a failure, you're actually incurring additional cost. If you have to rerun a query because the results didn't come out, you're incurring cost. So how do you actually find these issues upfront and be able to resolve it in a timely manner is also going to drive a lot of your cost implications. And that's the second challenge we majorly see in the customers that we are working with.
Thank you, Chandra. So next, Govinda, you actually run pipelines, so mission critical pipelines that are critical to many, even though it's a single company and you're serving so many customers, right? What can you tell us about your own journey and the challenges you see?
Thank you. First and foremost, I'm stoked to be here in this such a fantastic group of technology enthusiasts. And I've been hearing Anuj talk so eloquently about the problems in the data space, about observability. This is not something that is a classical science. This is a day-to-day problem. So just a quick intro about me. Currently, I'm a head of engineering in Atlassian. I lead the enterprise data portability platform, which is around moving large volumes of data, right, between on-prem and cloud, say whether be it Confluence or Jira in the cloud, etc. In my prior role, I used to be a director at PayPal. I was also the site leader of PayPal Credit, where we were taking critical financial decisions around giving loans to merchants based on their transaction data. And prior to that, I was in Intuit, where I was leading the enterprise offering for their QuickBooks out here in Bangalore. The common theme that comes in all the three areas that I'm talking about is, and I wanted to intentionally give a context, is that data is a common factor in all the three roles that I've played. And all the three companies have also been in a stage of maturity where there is a focus on left shifting, there is a focus on consolidation of various roles, right? You are in a DevOps mode, quality and development fuses into one single role, right? So the boundaries of roles are also changing, and the expectations from an engineer or an engineering manager is to do multitasking at all the time. Now, even while we are in this journey, this is a slightly philosophical question. We never talked about observability way back in early 2000s when many of the jobs were related to mainframe. Nobody talked about observability. Nobody talked about latency. Why? Because in huge boxes, when you run your compute layer, it is so easy to identify where things are going wrong. So we have simplified our life through autonomy, through the advent of microservices and various other paradigms that come with it. The downside of that is as you build autonomous teams, you're also creating silos. And this is exactly the problem with observability. This is not just limited to data, but data, given the fact that we've got a lot of dependency on data. I'll give you a couple of examples, right? In one of the roles that I was in, and yesterday I was talking about it with some of the Unravel engineers who happen to be my previous colleagues too, the business executives would take critical decisions regarding investment, or even it could move your share prices right around a quarterly result based on how business intelligence data is generated around your subscription numbers in your cloud environment. That's such a critical data. And guess what? Bad luck for the data engineer who is working on the pipeline. 2 a.m. in the night, that engineer gets called because next day morning the EVP has to present the data and something is not tallying. How many of you would want to be woken up at 2 a.m.? I'm pretty sure unless and until you have nothing else to do in life, you don't want to raise your hand on that. Similarly, during the pandemic, and I was in PayPal Credit during that time, there were various phases. There was a lockdown. At that time, we wanted to change our risk underwriting policy. We want to tighten our risk underwriting policy. We did not want to give loans to a lot of people. And when the lockdown was getting relaxed in various parts, and it was a global product, when US was opening up, Europe was tightening. So how do you build in these built-in controls? And the business would expect magically that you turn on a bunch of switches here and there, change some parameters here and there, and your model would automatically take care of the fact that this region will have a tighter control on your capital, whereas in this region you have relaxed it. Unfortunately, your model can actually do that better, but your data is not that strong. And the problem is not with the data. The problem is with the pipelines that actually connect the data. So observability is mission critical, and in today's world, without observability, either you're going to have burnout in your teams, because many of the teams trust us, right? We would want to give autonomy. Along with that comes silos. So how do you connect the independent teams that are moving with various priorities together to achieve something which is business critical? So observability comes a very, very important role to play, and companies like Unravel, I'm so glad to see they are actually being innovators in this space.
There's a lot of great insights there. In fact, bringing out the data pipeline aspect, the burnout aspect, like why there is a bigger mission here rather than building tools that can make your SLAs be met, right? So with that, maybe Giri, like you have led operations teams, you have seen things from the bigger, operational mindset, right? Can you tell us more about your journey and what do you think some of the challenges are?
First of all, thank you everyone. Folks, this is a wonderful event. I want to tell all the engineers, leaders attending this session, we at Unravel, this is the first Dataops conference we're doing, and we do it more. Giving quick intro about myself, my name is Giriraj Bagdi. People do call me Giri. I work at Unravel. In my 2 decades of career, I worked at Cisco, eBay, Walmart, Intuit, various gigs, right? And the theme has been common in my journey map: operationalization, customer, and also basically bring the rigor for production rolls out, right? Personally, I'm super passionate about customer obsession, super passionate about making sure things are monitored correctly, observed correctly, and building a great talent and energy talent who can work with us. All right. Now, how many of you want to sit in a plane which doesn't observe? Nobody wants to sit down. I can tell you for sure. How can we have a data, without observing in place? I will segregate into the 4 personas. First is business and customer persona. They get fatigues. I do not know what to make decisions, right? Decisions are incorrect, right? We do not know what will happen, revenues next year or next day. So a lot of ambiguities without observability plays for business part of it. And guess what? Business relies on data scientists, data analysts. They lack, okay, quality of data is not correct. I'm not able to get real-time data. The models are not correct. Hence, they get impacted in that area. Now come to our engineers called DevOps engineers, Dataops engineers, SRE, poor guys, right? They struggle. I have to monitor the environments, I have alert fatigueness. Too many alerts coming in, velocity, variety of data. My SLAs are missing, and hence SLA missing, what to do? And guess what? I'm going to write multiple tools and support multiple tools, buy versus build multiple tools. We go whole 9 yards in that area. And as per leadership's concern, well, I need the dashboards. SLA not met, give me an RCA. Why RCA is not working? Cost is going up. Why additional resources are needed? So basically, without everything in place, the demand is, wish I had a single pane of glass, which tells me everywhere from infrastructure to top level, how the data can flow across.
That's a lot of great insights, Giri. In fact, you touched upon something which I'll use as the context for my next question, right? Personas. So clearly there are challenges. So my next question is going to be, and we can again start with you, Akla, right? It's like, whose problem is it to solve observability? Who's responsible? In fact, who should all collaborate? Is it a collaboration thing? Is it one person team driving it? And maybe who should get fired if this observability challenge is not solved? So from the persona's perspective.
So wonderful question, and to that and to his point, I think data is omnipresent, right? I mean, it's everywhere, and it's not just the task of the ops or the infra team. So infra team manages data. You take care of change management doesn't work because there is a while we're using DevOps principles for data ops, there is an inherent difference there. In DevOps, you have a software product. One team is building it and another team is executing it, and so you know the responsibilities. But your data, as I said, is everywhere, right? I mean, you have every single person in the organization touching that data in some form or the other. So there are consumers of data and there are producers of data at every stage of the pipeline, and those producers and consumers could be people, could be apps, could be part of your data pipeline, could be something on the cloud. So I think it's an organizational culture that needs to evolve more than just processes and roles that define this. It should, right from the beginning, I think data quality is something that should be the key focus area of every single aspect in your organization that touches that data. And building that, and cultural changes improve value over time. So it's not something that you have a team or a person responsible for this and he or she does the job or doesn't do the job. It doesn't kind of work that way. It's a shift in your paradigm for your entire organization. And while that may take time, at the end, I think that is what is required for this.
Okay, so it's not a single person, it's a cultural kind of a shift, right? You go there, you grab the mic, so I'm sure you have something to say. Go ahead.
Yeah, so I think Akla made a great point that it is a team's responsibility across various layers of your stack to own the data. But my prescription for this problem would be a little different. We should treat data just like how we treat an experience, right? So if we were to draw a concentric set of circles, because that's where your layered cake architecture would actually take you to, the layer which is the outermost layer is the layer which is closer to the consumer or the customer. They are well equipped to understand what is going wrong. This will bring in a customer-driven approach to our observability. That means if a CEO or a CFO of the company would like to see a data and the data is not right, start seeing from their perspective. Or if you're actually solving for a CMO by bringing in recommendations for your marketing page, you would like to start understanding what metrics am I moving? What is the impact of my KPI or OKR if my data is going wrong? Because that will help you bring in a business context to an underlying infrastructure problem. Because and going back to one of my wonderful colleagues, Avik's point earlier, the infrastructure team, fortunately or unfortunately, is abstracted away from some of these high-level business metrics. They will not be able to understand that this pipeline went wrong or is not working. What is the impact, right? So it always works the other way. The ownership starts with the outermost layer, and each layer takes a responsibility of what is the expectation, what is my SLA with my consumer. That would help.
So if I have to abstract that, then a very consumer-focused mindset, use case-driven, and then start with, in fact, you mentioned a very metrics-oriented way to define it. What is the impact of incorrect data, let's say? And then what is the impact on your OKRs? The business outcomes you're looking to drive, and then work backwards from that. I would love to hear perspective from Chandra as well. Once again, I'll just add one more level to this. Right? Sometimes when it is everybody's problem, sometimes it's nobody's problem. So ownership, where should ownership lie? And it's okay to be distributed, but at the same time, where does accountability come in?
Yeah.
Love to hear.
Yeah, I think that's a fair point, right? I think within an organization, it's a collective responsibility, but finally, as you said, if somebody has to get fired because of lack of observability, these days what we are seeing is the CDO organization is where the actual responsibility is ending, because they are responsible for delivering quality data for business decisions. The construct of a CDO is coming into play where they are responsible for setting in the right processes. Maybe the CTO is looking at bringing in the right kind of tooling, but CDO finally is defining what those OKRs are. What is my responsible? What is the expectation of data? How am I delivering value, measuring the value of data? Am I having ROI from the data initiatives? So that's where it stopped. But as both of the panelists said, right, it is very, very important in terms of cultural change. Because a lot of times we see the problems are something which are carried on from legacy. We see people still using data as, I just bring in data, I do the analysis, I leave it there. I don't care if the data is there because it's not impacting anything. But when they move on to cloud, we see this being a major impact that it's creating. We have recently, in the past few weeks, we've talked to a few customers where they're actually having billions of assets that are sitting out there. 20% of them are never used. Right? And that is bringing down the time it takes for them. The pipelines are running slower. They're actually having cost impact. So the observability is also not just from, am I able to deliver data on time? It's also about, am I using the data correctly? Am I having diagnostics to analyze what is being used and what is not being used? Am I disposing it the right way? Right? So there are also other aspects of observability that are coming into this, and all of this is redundancy, rationalization. All of these are becoming the charter of a CDO to make sure that they are getting addressed.
Fantastic. In fact, I was relieved when Chandra said the CDO, the Chief Data Officer, should get fired, not the CTO. Thank you. So in fact, we actually had a real data quality problem just this week itself, like everyone. So we would love to hear your perspective.
So I'm sure all of you would have received security vulnerability JIRA. Raise your hands. Who received the security JIRA? Right? Did you understand the security JIRA, what was written inside that? It was so hard sometimes, right? It can be application security, it can be security infrastructure, or security random somewhere deep in the Java code which nobody can understand. And guess what? We as an engineer are responsible to solve the JIRAs, correct? So similarly, data, security is nobody's problem. Then what will happen? Gradually the industry shifted, that we have a security team, etc., debug, etc. Now, in the data also, currently there's nobody's problem. It all depends on the scale of organization. There's small company, medium-sized company, large company. If there's company which is very small, it is of course everyone's responsibility. But in a larger scale company, their data platforms team, their data scientists team, their data ops team. So I go back to Anuj's slide, if I step back, in which there was a data is a new oil, in which he mentioned the AOR responsibility on each of these oil to get filtered, correct? So right way to go is data is a new oil, perfect. And the oil is increasing more and more with velocity, veracity, and the AOR has to get divided across a stack, right? How to make it happen. For example, if there are product fixes done, which nobody knows in the DevOps, DataOps, what the heck is done fixed there. We should know what level of changes have been done there. Then you go down. If the pipeline has been changed, and the change in the pipeline can be anything, people should know down the line. So the SLA can be met. There's a change in infrastructure. I decide to move to AWS Cloud or Azure Cloud or Database Cloud. People should know all about it. So more awareness across the organization, divided responsibility to conquer that.
Fantastic. I'll then use that for the context for my next question, right? Which is, again, I'm sure a lot of the people in the audience are also thinking like, how's my own career going to grow? Like as observability and like things like that, right? What advice do the panelists have on, like, basically there are challenges, we need to solve these challenges. How do you think about building the right teams or the right awareness? Is it a build versus buy decision? Like we should bring in like cultural changes, so we should have like be maybe hiring people to like solve this kind of problems, or we should be hiring people who have this mindset. So I'll translate my question into like two parts. One is it going to finally become a build versus buy decision? And in either case, how do you think about building the right teams, and what are the corresponding career opportunities that anyone who's interested in this space would actually get? It's a loaded question from build versus buy, but really I want to think about how do you kind of build the right team or the right tooling, on how do you kind of go about from that perspective?
So again, adding to Giri's point, I think I mean, the answer to this question lies in the scale of the organization also. So if, I mean, and now every company, every person is a technology person, or every company is a technology company. We are no longer talking about technology companies as those software giants, right? Everybody uses technology. Most people use the cloud. I mean, multi-cloud and hybrid cloud has kind of become the norm. So with that and the big data era being the current era, what I see is if there is a solution out there, I mean, that Unravel has built, I would definitely recommend using that solution first and seeing if that fits within the context of that organization, and not like go reinvent the wheel, because this itself is a process, right? And as one gentleman asked this morning, I mean, you're introducing more processes, another tool, adding to the same observability stack and more complexity. So building that process or that tool itself, you know, unless you have those resources and you really understand what exactly you need from, you know, that tool, you could probably build it. And if it's not available, if it's available in the market, ready to buy or consume, I would say go for it. See if it works for you. If it doesn't, you might want to tailor it and then plan to build your own. And that is, you know, building the tool or building teams around this aspect of observability, this aspect of data ops. So go for what's out there. Doesn't work, then build your own.
So try something that exists, and if that doesn't work, then on that process you learn what is the right thing for your environment that will drive your success, and based on that, proceed. Yeah, maybe yeah. Go next.
Yeah. So if I take a step back, I think interesting points, right? If I take a step back, the way the data pipelines are working are consumed today, there are three broad categories, and you could classify any ways depending on how you want to look at it, but the way I look at it, there are three broad categories. One is the traditional analytics, business intelligence way, where you're actually driving business outcomes or business decisions based on data. That is the first part. The second part is product, and AI today comes with the product, right? Smart products are the norm today. So I'm not going to take AI as a separate fad or something different. It could also be around, say, the Flipkarts of the world, the Walmarts of the world, or Amazons of the world. You would see thousands of Kafka streams coming in at play with various parts of the order management system actually being executed by your consumers there. So your order management system is actually built on data pipeline, which traditionally we don't call under the data pipeline, but there is still a value there in monitoring that data pipeline because that impacts your key business KPIs. The third part, which is something relatively new, I personally was surprised to see that this is also happening, that your traditional microservices observability data is also flowing through your data pipeline. Because ultimately there is a desire to identify what is a technology outage impacting my business KPI. And this is a tough question to answer, right? My system was out for 1 hour. My order management system was out for 1 hour. How much revenue did I lose? End of the day, it is a question between CTO and CFO. They need to report to the street that we lost revenue because of a technology outage. Banks have to do that today, right? HDFC Bank in India, I'm sorry to take names, was actually pulled up by the regulator because of outages in the infrastructure that they had. Right? So these are the three broad categories of use cases. Now, if we were to take a step back, way back in 2010 or 2006, when Java was ubiquity, JMX was the popular standard that we were looking at, right? And over a period of time, how many of you know Ben Siegelman? Ben Siegelman actually started a company and defined open telemetry, which is now part of the industry standard, which actually talked about the traditional observability of your microservices world. Here, we are actually having solutions around data, which is a niche area, and companies like Unravel or the professionals, the technologies who are working in this space have the potential to define a new telemetry standard for data and standardize, because as was pointed out, you live in a very hybrid world. The same company may have something on-premise, may have something in AWS, in Azure, etc. How do you ensure that you build a common framework, at the same time provide the plugin capabilities or customizabilities which cater to the needs of a particular enterprise that we need. That is where we are headed, because that's been the traditional direction for any technology that we see. Standardize your foundational layer, provide the ability to customize so that you can meet the enterprise needs. That's where I see it.
Awesome. So Chandra, I would love to hear your thoughts as well.
Yeah, I think this one I would probably look at two different aspects of it, right? One, of course, as Akhil said, I think if you have an option there, if there's a product out there to actually do the bulk of the heavy lifting. But when you're doing that decision, one of the key things that you need to look at is how open is the product. Right? Because as I said, enterprise context is very important. So we need to have open interfaces where I can bring in that enterprise context. The second is also the culture part of it, because a lot of times, all of us would have done when we are building applications, when we are modernizing, we do a lot of product evaluation of other things, leaving aside the observability stack or the products. Whether it's an ETL tool, whether it's a reporting tool or a data platform, our product evaluation criteria also needs to focus a lot on observability. What are the things that they provide, right? Recently, I was doing one telemetry assessment for a Power BI landscape for a European client. One of the things we observed is there are metrics that are available in terms of failures and other things, but the logging information is not enough to actually pinpoint what the error is, right? So some of these metrics have to start getting into the evaluation sheets, which is a cultural shift, because if you want to have a truly observable platform, it's not just enough for you to have tools that do observability, but every product in your landscape, every tool platform also needs to have a higher level of maturity. And that's something which is a cultural shift that needs to happen as teams start evaluating products.
So to summarize what both of you have said, again, purely think in terms of building the teams that can make this happen. So engineers who come with understanding of these standards, engineers who are able to build in these observability early on into these pipelines, make that as part of the pipelines can actually help address these problems proactively. Giri, would love to hear your thoughts as well.
So there's no single bullet to this answer, right? The reason is people need a single pane of glass, again say, as a command and control mechanism to manage end-to-end, right? Tools can be, we have tools to infrastructure level tools to host it. We have the orchestration tools like Tableaus of the world or Airflow to do that. And the third tool is gluing all things together, actually. In this room, how many folks have built up the tools? Forget infrastructure, forget the orchestration. How many have built up the tools? Just raise your hands. Okay. How many of you have bought the tools? Right. So it's an equal range, right? So basically, there's a demand whereby how I can end-to-end combine it, right? Building the tools needs what? Again, a debate with the engineers' technology. Java versus Python. We started a big debate, 9 years done, right? Okay, where to host? On-prem versus cloud, and the debate happening. Then the UI, there's so many UI into it. Kinder UI versus, so the whole debate start happening. And guess what? Business is struggling. Forget tools, give me something which I can see, right? That's A part of the problem. B problem, go to orchestration. My pipelines are very slow, and hence I'm not able to debug. Okay, here we go. We hire an expert who knows Spark Guru and tell me debug my Spark jobs. And we say n number of days to debug Spark jobs, changing hundreds of parameters and performance tune the Spark jobs. Guess what? What's happening? My SLA is getting missed. My data, what you call as business stake is still, I'm not able to do the numbers out of it. And guess what? I will use the cloud. The costs start going up. And here you go, call from operation teams. Please shut down your instance. The cost is going up. Shut down EMR. It is so much resource. Or shut down your Databricks workspace, right? So basically, there has to be a way which combine all this together, whereby solving a need for the business side, for the data analyst, for the basically DevOps engineer, DataOps engineer, and the leadership, giving them the visibility what persona they need, right? So sometimes you buy it, sometimes you build it, or sometimes you buy it and build an API top of it. Ultimately, all extract events, logs, and two basic provide visibility.
Terrific. My favorite question is left, but I can see time is also running out. I definitely want to give the audience a chance to ask questions to the panelist. Until we run out of time, I would love to take a few questions from the audience. You have asked a lot of questions, so let's give some time to others. Who else? Yeah, we'll come to you, but who wants to ask a question? From this side, everyone is very quiet. I want a question from this side of the room. Nobody has a question? Go for it then. Okay, so that's a great question. So I'll summarize the question as like there are all of these teams. In fact, this is a point that Govind actually touched on, right? All of these autonomous teams, and now using the word that he used, which was used, right? Knowledge gaps are emerging, and how serious of a problem that is, and what's the solution to fix it? I'll have Govinda actually take that question.
How I wish all PMs knew technology, right? Because they are not meant to know. I'm not making fun of PMs, but they're not meant to know, right? If they know it, it's an added advantage for you as an engineer who can actually collaborate with them. So that there lies the answer. So to your last question, have I solved the problem in the enterprise? No. That's job security for me, right? Otherwise, they wouldn't need managers in the system because, you can have a bunch of engineers manage it. So some problems do not solve. I'll talk to you offline about some problems that shouldn't be solved, right? Jokes apart, the fundamental principle is you give an autonomous team autonomy and focus area, they are much more productive. You dilute the focus, you ask them to do many things. They may do it very well because there is a P0 or SEV0 that the organization is grappling with. All hands on deck, everyone works fine. But is that a sustainable model? Will that cause a burnout? So you have to consider employee engagement, employee well-being, along with how do you structure your teams. Now, we should not miss the first part because some of the high-performing teams may be high-performing for burst of time. That's not what you want over a period of time. You want sustainability of your teams. From that perspective, giving that autonomy is a better option, but the way to solve your organizational problem is to have better interfaces. Better interfaces can be good handshakes between teams, team leads, or product managers or program managers, or it can be better interfaces between tools. Give them good tools, give them good interfaces. We can actually make the silos talk to each other. The problem is when you don't have tools or when you don't have the right point of contacts who act as interfaces, that is when systems collapse. That's just my opinion. Love to hear the panel's thoughts as well.
Anyone wants to take that question? Yeah.
Yeah, I think some part of what you said in terms of knowledge not being shared can be addressed by technology. What I mean by that is there are a lot of tools out there right now which can actually extract some of the information out. Just enough information may not be the entire logic. For example, one of the classic problems that is there, as you said, APIs are getting deployed. You don't know where they are getting deployed. Now the person who developed the API may not need to know it. At the same time, the DevOps engineer knows where it is deployed, but he doesn't know what that API is connecting to. So there are ways of extracting information out of the API that are published through the API registries, through the code, to scanning these things and making that enough information available. It may not give you the full context. Everybody doesn't know everything. There is, maybe you can get 50% there. One example I can talk about is a few years back, 3 years back, we actually were doing a tool rationalization exercise for a large bank. It's a global bank. They had about 400 BI tools in their landscape. And we had no clue of how they're actually using it, who is using it, what are they using it for. There were a lot of overlap. There are about 30 tools just for reporting visualization. So one thing we did was, of course, they had their own information management system and all, but as you know, most of them enter the application information when the application is created, but nobody keeps it updated. So one of the things we identified is they had an in-house computer division which actually scans all the servers to find out the software that is installed on it. Right? From there, we tied it back to who are the owners of these servers, which are the applications using these servers, and we are able to relate back saying these are all the applications using these tools. And then finally, the last mile connectivity, we had to actually launch a quick 5-question survey to see what are they using it for. So a mix of technology and these kind of things is what will help us in identifying what is being used for what. And it will still not improve the knowledge of the business process and thing, but we can get to a certain extent through some of these approaches to improve the visibility of what is being used.
Thank you.
Just to wrap it up, it's a very common problem, and training can solve, but to a certain extent, right? How I done my previous gigs was anything which is repetitive pattern, how to solve by automation. That's something stand I took. This happened again. Let's solve automation. It's not possible to train every machine learning model. Not possible everyone to train infrastructure. But common patterns, take it, automate it. That's one of the route I took.
We can take one more question from the audience. Yes.
You wanted this area, right?
Yes.
So basically it is a question as well as, maybe just a observation. So today morning when I was coming, I was talking to the NA sales leader who is trying to, sell similar solution. And I'm sure we'll talk about, competitors in this space like Splunk and all. But it is a big financial organization who is not ready to buy product. Naturally because of, InfoSec audits and even onboarding a product like Unravel will take 6 months probably. So they're trying to build it. So I think Giri touched upon build versus buy. That debate will go on. So if I have to take top 3 reasons to make sure that this sale happens, and we are touching upon technology and PMs and all, but the sales guys are really those who will front end this. So that is one thing. Maybe we can take offline and discuss about it. And in fact, I was coming to you to talk about that. So build versus buy is a big debate, and how do I enable the sales guys to make sure that they can sell it very quickly? That's one. And the second thing is from the technology perspective, observability is one thing, but actionable outcomes of it, right? That is the key thing. I can monitor, just take an example of Snowflake, right? I can monitor the billing going up and down. But is it possible to give exactly, you can take this action, which will improve? So those 2 things. I just wanted to point out, it's not a question, but.
No, it's an awesome question, right? In fact, that's the essence of this build versus buy question. If you have to convince your boss to either bring a observability solution, or even I need resources to build an observability solution inside, right? What are the top 2 or 3 reasons that you will give to bring those resources? Maybe, who wants to take that question? I'll talk to him during lunch, but who wants to take that question? Chandra, you want? Not necessarily build versus buy. It's like, how do you make a strong case that, in fact, the way in which this gentleman put it was like a salesperson going to sell, right?
Yeah.
Sure.
Yeah, so if you want to basically sell the idea of observability to, if you want to
even
sell the idea.
not even like building, or not even like buying, like even for build. Internally, a team wants to make the case, but how do you make the top 3 reasons for observability?
In the current world, it is pretty simple, right? Because at a top level, they are either looking at reducing their cost of operations, or they are looking at improving their business outcomes. Both of these, observability is critical, right? You'll have to be able to quantify that part. An example, when we talk of FinOps, right? We go to the market, we clearly call out saying that we are going to reduce 20% or 30% of your cloud spend because of observability. I'm able to manage, I can see where the cost is going to. The second part of it is if I'm able to preempt failures in your data pipelines, I'll be able to deliver data to you, which means that your business outcomes are accelerated. You don't have to wait for things to happen. Recently, for one of the Australian telcos, we created a prototype view of their data pipeline. Right? This is something that delivers data for their customer service group. And if the pipeline is running slow, which means they can't relate to their customers well, they will be using stale data. Now, the problem they had was previously they used to know that the job is running slow, but then they had to look at the last leg of the job, look at what is the problem, then go back. It used to take a lot of time to resolve. What we created is a pipeline visibility across the entire landscape. There could be 5 or six different systems like we saw in the first slide. It's a complete mesh of architecture. Every single node in that pipeline is even infrastructure or tool or anything. You could pinpoint where the problem is, directly go fix it. If you are able to make a business case around these elements, I think it's a good case for build over buy.
Absolutely, and I think the point you touched is quantifying the outcomes for the business is the most important. If I say 30%, but of what? If I say, like he said, right, HDFC was, they had to go through the regulations. So if I can give exactly from 5 million, you can go to 10 million, I think that is the case that you will win.
With that, in fact, I realized that these 4 panelists are what are sitting between you and lunch. In fact, I can see that Sunil said in the morning that he's also looking for lunch. So he's just standing behind us. So I would like everyone to thank our panelists. Thank you.
Check. Once again, while they are posing for a photo, once again, we'd like to thank Shivnath Babu for hosting the entire panel. Govinda from Atlassian, thank you so much for being here with us. Akila from Dell Technologies, Chandrasekhar from Infosys, and Giriraj from Unravel. Guys, give them a round of applause. And that comes to the end of a brilliant panel discussion. Hope you had a lot of takeaways. Just before you guys break out for lunch, I'd like to remind you on a few things. There's going to be a QR code put up here, which is the Meetup QR code, which is going to allow you to be a part of the community. So all of the slides that you witnessed here, any of the links that they'd like to share would be a part of this group. Cool? Second up is the LinkedIn. I think some of you guys are having an issue with tagging Unravel data on your LinkedIn posts. You can find it if you just put @Unravel space data. So you'll get a drop down and then you can select the company name. Cool. Third thing, there's the Unraveled booth outside. If you'll have any questions about the product or the services, you all can get in touch over there. Yes? Hey. Hello? Yes? All right, are we ready for lunch? I'm very hungry. Guys, please get up, make your way out to the exit on the left. There's a door there, and then there's an exit at the back as well. If any of you all want to use the restroom, and the restrooms are full, you can also use the restrooms at Joffrey's. And just follow this hallway down to the right from the lobby. You have more space. We're going to be having you back here at 12:15 for the next speaker session. Thank you so much, guys. My bad, 2:15. Thank you for catching me. This is going to affect my appraisal.
Agenda for the next half. We're going to be doing a quiz soon. So I would like all of you all to scan this or go to your lanyard cards with the QR code, and if you scroll down, there is a landing, like the landing page that it redirects you to. It has a button which says play quiz. So I want you all to open them. I'm going to give you guys a few minutes to open up the quiz. A lot of exciting prizes available. Neha ma'am, could I just have you? Once it's here? Oh, okay, awesome. So really cool gadgets to be won out here. So in total we have 6 prizes, right? 3 for the quiz and 3 for the social media competition that's going on. How many of you guys finished your LinkedIn post? Let's see. All right, those of you who didn't, give it a shot, guys. It's going to be worth it. Just break down whatever you learned in this conference. Put up a picture, maybe with you, with the background, or with some of the speakers. And it's like you're just documenting what you spent your day on, right? And in return, you could be a lucky winner. So give that a shot. Once you guys have signed up, use your Google account, all right? Sign up with your Google account. This is for your quiz. We're just prepping you. We still have a speaker. Abhishek? Okay, so let's see. Everyone on my right, the extreme right column. Have you guys signed in, logged into your quiz accounts? Yes? So confirm my seat. Have you guys completed that? All right, so that's good. Everyone facing the podium right here, everyone's done? Anyone not yet completed, you all are having issues? If you all are having any issues or you all or you're having technical difficulties, I have my good friend Abhishek here. Can you guys say hi to Abhishek? Hi Abhishek. And Richesh. Say hi to Richesh. So they can support you with any of the technical difficulties that you all are facing. We also have Mr. Ganesh here. Can you guys say hi to Ganesh? Yes, so he can also support you on the same. Everyone on this row, have you guys signed up? Yes, through your Google accounts. Do you have a problem with the sign up? You're good. The last column. All right. So I can continue on that. And we're going to move forward with the next speakers. All right. Mind it, that was intentionally plural because we have two wonderful ladies stepping on stage. And they're going to be talking about data observability. The force awakens. Can you move to that slide? Does anyone else want to scan this QR? I think we have some people who've just stepped in. If you could just talk to them and just catch them up on what they have to do. That day over there, the gentleman there, so just stepped in. So you could just support them on what they'll have to do. Also, once again, anyone who's updating the LinkedIn posts, these are the hashtags, hashtag DataGeek, hashtag DataOps, and hashtag DataOps Observability, and tag at Unravel space data. That's when you will find the company's LinkedIn profile. Yes? All right, guys ready? Okay, let's quickly introduce you guys. All right, so up on the panel, like who's going to be the speakers while they just set up for sound check. Let me just quickly introduce them. We have Sona Samad over here, guys. This is the part where we clap and cheer them on for taking up the stage, right? And we have Pallavi Angraje, which is a very interesting name. For the first time I'm hearing that. That's Pallavi Angraje and Sona Samad. All right, a little bit about them. They both work with Intuit. I'll tell you a little bit about what Intuit does, but first let's know our speakers. Sona is a staff software engineer at Intuit, backed by 14 plus years of IT industry experience with big data based product and service development. She also enjoys giving simple solutions to complicated customer queries. That's right. And we have Pallavi, who is a software engineer at Data Solutions Engineering team of Intuit with 5 years of experience. She's also worked with Samya.ai. That's part of Sony India, right? No, both are different. All right, so my bad. Samya.ai is one company, as well as she worked with Sony India. And she has huge experience in building large-scale data pipelines on AWS, Azure, Python, and Spark development, right? Handing over the stage to you guys. You guys ready? Yeah. All right, guys, come on, let's cheer the next speakers coming up on stage. All the very best.
Hello? Okay. I'm audible, right? Yes. Okay. Hello? It's good? Hey Sona, yet another data issue. There was a significant drop in the number of signups, and it was for QuickBooks product. You know what? All our data pipelines ran fine, but there was this issue highlighted in the BI reports and caught by our analysts. I don't know what's going wrong. We do have validations in our pipeline, but nothing seemed to work. I don't know how do we prevent it even in the future.
Yes, Pallavi, you're right. This is not a simple thing to resolve, right? And does it sound familiar to you all again? You have a data pipeline that runs without any obvious issues, but still the customer is not happy with your data. Yeah, we are here to tell you how we actually solve this problem. Hi everyone, I'm Sona, this is Pallavi. And we are here to give you an overview on our experiences in data observability and to see how we achieved engineering and operational excellence in the data solutions platform in Intuit. Well, all right, let me just give you an agenda of today's discussion. We will talk to you about the Intuit data ecosystem and why is this data important to us? And then we'll be also talking to the quality challenges we face as data engineering team and the principles of data observability we follow in Intuit and how we achieve data quality at scale using these principles. All right. How many of you know about Intuit? I know like you might have heard about Intuit a lot. Well, we are a company which is actually working on the finance software platform. And our mission is to power prosperity across the world by helping our customers make data-driven decisions. We have actually products like TurboTax, QuickBooks, Credit Karma, and MailChimp. And these products help the customers help to file their tax returns or simplify their finances or to increase their customer base. Now, as you can see here, this is actually the report that is published by Intuit on 2021 shareholder learnings. And as you can see here, we have millions of customers using various of our products. Now, what is behind this? Like we have data coming from multiple sources, like OLTP or Clickstream or many other sources. And the data ranges from terabytes to petabytes. Now, handling this such large data, we understand like with large data comes bigger challenges. And my colleague Pallavi will now tell you what are the challenges we face and why this data is important to us.
Well, we saw that Intuit has great products and it also has huge customer base. And we have several people at Intuit who closely monitor our product data so that our users can have great experiences with our products. Well, now let's take a look into a typical analytics dashboard at Intuit. So the one which is shown here is used by more than 90% of our data consumers, and the user group involves the executives, people from finance, marketing, data science, data analytics teams. Here you can see that we keep track of various metrics for the current year, the previous year, and the forecasted values to understand the customer behavior and to take business critical decisions. This particular dashboard refresh has a strict SLA of 7:30 a.m. PST. Now let me tell you the challenges that we face as data engineering team meeting this SLA, ensuring data quality, correctness, and freshness. Well, before that, I want you to meet someone. Meet Lisa. She is a data worker at Intuit. She is the one who highlighted that there was an unexpected drop in the number of signups, and it was for US region for the past week. She looks worried because the numbers on the dashboard don't look great, and she doesn't even know whom to contact and how to get this data fixed as soon as possible. We all have several people like Lisa in our own organizations who work day in and day out with the data that we process. They are the ones who are impacted the most when something goes wrong with the data. They come back with the issues, and later even we find it very difficult to quickly identify and fix the root cause. But is that the only problem that we face? No. Let's now have a closer look into what are the various factors which are not well in our ecosystem. As Lisa correctly pointed out, incorrect reporting is one of the major problems for us. But we also have high mean time to detect and recover from the data issues, which results in more number of data incidents. And sometimes we miss our SLAs, and there are parity issues in some of our tables, and which requires us to do historical data refreshes as well sometimes. So these are definitely the areas that we need to look into and fix going forward. Let's go step by step and see how we can solve these. First, let's have a look into a very high-level architecture of data processing platform at Intuit. So here you can see that we receive the data related to our products through internal and external sources, and we process it using stream and batch processing platforms. And we also make use of data analytics platform for ad hoc querying purpose. And finally, all this data is fed into the reporting platforms from where the end consumers of our data make use of the reports that we have. If you see on the left-hand side, there is a separate flow where the data from the tables is directly consumed by the machine learning platforms. They generate the forecast and contribute back to Intuit products, and there goes a cycle. Now let's see what are the opportunities for us to improve here. So in the source layer, currently the source of failure and delays are not identified always. There are event parity issues. During data processing, not all defects are identified. And on the reporting layer, incorrect reporting and SLA misses are the major problems for us, which even results in prediction model defects. So now, Sona, since we have an understanding of the solutions or the problem areas that we need to solve for, right? Now comes the challenging part. How do we come up with a solution which is very generic as well as can seamlessly scale to the extent of the data that we have at Intuit? What do you think about it?
Well, in Intuit, we believe in falling in love with the problem. Now that Pallavi told you like the problems we face and the challenges we have, let's see how we can solve this and achieve data quality at scale. All right, before just going to the solution, I just want you to recall the problem once again. All right, so we're going back to Lisa. So Pallavi introduced you to Lisa, right? Lisa is actually having an issue with her sign-up counts. And she didn't know whom to reach out to and how to get help on this. And that's when Lisa came to the data engineering team. And we have to go step by step to understand what are the problems we need to identify and fix so that Lisa's issue is resolved. All right. So the first step in that is to understand the data lineage. By data lineage, I mean the parameters and the attributes that actually come up and aggregated into the metrics that Lisa was looking into. And for this, we have to go back and figure out the sources and the source pipeline that was actually ingesting these parameters. Once we got the data lineage, the next step was to understand and fix the issue by adding data quality checks and circuit breaker checks. So these are generalized business rules as well as sanity rules we have added in the pipelines to ensure like inequality issues is detected and alerted to the developers. Once this was done, we could have actually done the solution of the problem, but we didn't want to stop there because our dashboards are actually populated from pipelines from different pipelines and different sources. That's when we need to go back to the dashboard and do a triage on the dashboard to see if things are good over there. And that's where we came to the data triage process, which is actually validating the data across different ETL layers and figuring out if there is any disparities between the data that is in the aggregated level. Now then, we have done the data triage process. What if there are underlying issues that we haven't figured out at any point of time, which is identified neither by the developers nor by the analyst? That's when we added anomaly detection checks. These are actually ML-powered data anomaly identification, and it does a trend analysis on the data. In this case, we took up Lisa's data and did a sign-up data trend analysis to find out there is something missing over there. Now that I talked about multiple homegrown frameworks in Intuit that we used to do the data quality checks at different levels. Let's actually go back and see how they are each implemented so that we are actually preventing data incidents. All right. So what you see here is actually a traditional way the pipelines are set up. So the pipelines basically are actually chained, and one pipeline will be feeding to the other. Say an ingestion job will be feeding to a processing job, and then to an analytics job, and so on. What if there is an issue in the first pipeline? This is not detected, and the data flows go on, corrupting the data lake and creating incorrect reports. That's where we need to introduce data quality checks in between. All right. So what you see here is actually a set of data quality checks we have added. The data quality checks have two steps in include. One is data validation check, and the other one is circuit breaker check. Data validation checks are kind of the data quality checks, where actually it checks for the data issues, creates an alert, and resumes the flow of the pipeline, because these checks are not very high priority and can be fixed later on without affecting the SLA of the current pipeline. Say there are a few null values in your table column. Maybe it is kind of 2 to 3% or 1 to 2%, which can be ignored at the first run, but later on we need to fix it in the long run. Such checks goes into data quality check. Now we don't have to make sure like all these checks should be kind of allowing your pipeline to finish, right? There can be a case in which your ingestion job is failing and ending up with your delta data coming as 0 in the target table, which is going to affect your entire data flow and your final dashboards. And that's where we have the circuit breaker check in place. So the circuit breaker checks have high priority alerts. It breaks the flow in between, fails fast, and the developer need to go back, fix the issue, and then only the flow resumes. Now that I talked about the different type of checks over there, let's just see the design considerations behind this. So one of the major design consideration is to use multiple source support. This is because I was talking about in Intuit, we actually take up data from multiple sources. And every single time, we don't need to make a different data quality check and a framework. And the entire system needs to be pipeline agnostic and can be plugged and played for any kind of pipeline we are using. And that's where it comes into place. Now we are also using the performance consistency and scale, because we are actually dealing with data on large volumes. As we were talking about, we are dealing with data in terabytes and so on. And then we need to ensure like these quality checks are not actually part of the existing framework. It should be configurable in such a way that the users can actually dynamically add the data quality checks on the fly. And every single pipeline, as you all know, the quality rules will be different. All right, to ensure like all these design considerations are done, we are actually set up the entire system in AWS infrastructure. We were using Spark for processing and so on, and Scala classes for our framework development, and we use Splunk and Wavefront for our dashboarding. But these are kind of independent components and will be connected or decoupled in such a way that we can even use a different kind of UI or a monitoring mechanism to continue. All right, I was talking a lot about the data quality checks. I'll just tell you like how this data quality checks looks like. So let's see the data quality library over here. So this is kind of an enclosure of different kind of classes that's used to do all the processing work to figure out the data issues. Say you have a comparison class or maybe a validator class. When I say comparison class, it might be taking up data frame from previous two sources, like similar kind of data frames with say the same kind of primary keys or whatever. And it does a comparison between these two data frames and give you a comparison data frame output. As I was talking about, the whole thing is running on Spark for now. That's why I'm talking about data frame here. And also the validator class kind of takes a union of all the previous data frames from all the previous steps of processing. And now it actually do a quality check on that and gives a final validation output as a result. And the data quality rules, as I was talking about, is actually independent of the existing framework. User can actually add in the data quality rules as a config file. So if you see here, the user can actually write any kind of rules, including some SQL queries. So if you need to do a specific SQL query as a quality check in your pipeline, you can actually introduce that through the config file. Also, the user can add specified or customized Scala classes to do more transformation on that. So it's everything is kind of config driven over there. And I was talking about the reports. So reports right now is like we have a single window for having all the dashboarding done, just like the Splunk dashboards or the Wavefront I was talking about. And also multi-channel reporting. Maybe you can get alerting over there, like you can get Splunk alerts or maybe Slack alerts or maybe email alerts on any of the quality issues. Well, you can see here, like, it's not clear over there, but still, this is like a report that comes in with multiple reports over there for each of the stages of the pipeline, and says like which of the stage has a failure and what is the reason, or which are the columns for which it has an issue over there. And every single calculation here is made upon based on the config rules that the user has already fed into the system. And here, if you see here, one of our quality job has actually failed. And that was actually for the ingestion job for getting the sign up events from the QuickBooks Online source, and which actually says like a reason why the Lisa's final metrics had an issue. Now, like I was going back into the how we could detect this using a configuration driven predefined rules, right? But do you think like that's the only thing we can do? Because there can be cases in which there will be anomalous patterns or trends which is not identified and added as specific quality checks. And that's where we try to introduce something like anomaly detection checks into our pipelines. All right. So ADS checks are actually a service that we are utilizing, and the anomaly detection is a homegrown framework in Intuit, and we are utilizing its capabilities in our pipelines to do the checks over there. Let me tell you how that works. So ADS actually needs to get data. As you know, like any machine learning algorithm that needs an anomaly detection needs to have mostly it works best if you have a time series data. So we convert our target data into a time series data with timestamps as well as the specific metrics in question that needs to be checked for the trends. So in our case, probably it was Lisa's case, it will be the QuickBooks Online sign up counts that would be our metrics in question. And that will be going as the time series data set. Other inputs that we need to give to the system would be like the config files. So the configs includes the scheduling of the jobs that we need for ADS. So any machine learning algorithm that you know should have a training and inference jobs to be run. So we'll be scheduling like when this training jobs and the inference jobs needs to be run. Also, we need to mention on the specific business rules in which the model needs to be built in, because the requirement is different for each pipeline and each user. So once we giving all the required inputs, there is a training pipeline that is internal, which actually is scheduled to run periodically. The reason being, the model once trained might be stale after a point of time. So we need to ensure like the trained model is refreshed and we have the right data at the right time. And we'll have an inference pipeline, which is either scheduled or can be triggered automatically in a serverless manner whenever a new data comes into your system. So the inference jobs basically takes the new data, compares against the trained model, and if there is an anomalous pattern detected, it actually flags an anomaly. And the triggers will be created and people will be alerted. Now the question is like, what is a specific algorithm we need to use for that? And that's when we come up and understood, like it's not one algorithm, but an ensemble of multiple algorithms should be added for this check. And it should be actually configurable by the user, saying like, I might need a specific algorithm to do my anomaly detection check, which is not useful for some other team or another pipeline, which is doing a different type of data. And there can be more than one algorithm that should be doing this. So there are multiple algorithms, and the model trained artifacts that I was talking about, which is actually stored in an object store like an S3, would be created for each of the specific algorithms. Now once the models are created for each of the algorithm and the anomaly detection is done, there's a majority voting done on each of these anomaly outputs of these algorithms. And based on the majority voting, it actually flags as an anomaly, which means like a lot of noise that might be created by a wrong algorithm can be reduced. Now that I was talking a lot about how it was working, let me show you how we infer data from this. So our anomaly detection process basically creates a logs that is actually forwarded to Splunk in our case. So what we do is like we have a dashboard that is built on top of Splunk. And this dashboard will show you a lot of information, including the means, variance, and other information on your data, as well as a pattern of how your counts looks like in your data compared to the previous or the old historic data. And that's where if you see the specific case of Lisa here, she had the sign-up counts issue. So we actually tried to look into Lisa's data sets and the pipeline that was creating it. And what we found is like there was a pattern that was already happening. And if you see the pattern, it is like for weekdays, there is a high, and the weekends, there's a dip over there. But this pattern is kind of continuous and is expected, which means like the algorithms we have tuned for will never create an anomaly for that. But at a certain point of time, one of the dip was too huge that it was actually figured out as an anomaly by 3 different algorithms. And because of the majority voting, 3 out of like 4 or 5 algorithms notified it as an anomaly. We found like there is a problem over there. So even if the data developer hasn't written a specific data quality rule over there for this particular case, for which the developer is not aware of, this anomaly detection would have been easily figured it out, flagged for us, like there is a problem over there, go back and check it and figure out if there is something to be fixed. And that goes like the way we have implemented our anomaly detection using ML algorithms. All right, I was talking a lot about these two processes, but we didn't have to stop there. We need to have another set of data validation that we are using data triage process. And I will be inviting Pallavi once again to come back and tell you how we are doing that.
Well, even after having multiple anomaly checks in place, often it takes time for us to identify, analyze, and confirm any data issues as data engineers, because we have hundreds of data pipelines with us. So it was important for us to identify any data issues at the data pipeline level itself, and that's when we came up with the idea of building data flow triage. Let me explain how this works. At Intuit, we believe in building modular data pipelines, which means that we have designed separate set of data pipelines for moving the data from source layer to landing zone, then to data mart, and finally to the reporting layer. Now we build the validations at the intersection of each of these consecutive layers. Building such validations takes expertise in the business domain as well as a great understanding of all our data pipelines. But once we have them in place, we see the great advantages that we get along with it. So here in data flow triage, we keep track of the metrics at KPI, region, and product combinations for the selected date range, and triage summary gets generated after comparisons and validations, and it populates the corresponding dashboard and also sends out the alerts in case of any red flags in the data processing. Now let's get back to the problem that Lisa had pointed out earlier. She said that there was an unexpected drop in the number of signups, which is the metric, and impacted product was QuickBooks Online and the country was US. Let's set these filters in the triage dashboard, and now it clearly indicates that there was a problem with one of the jobs that moves the data from source layer to the landing zone. And again, if you see the graph below, it highlights that there is a significant drop in the count of signups as well. Now, when you have the details at this granularity, it becomes easy for anyone to quickly identify the corresponding data pipeline which takes care of processing this data. And now we no longer have to be dependent on the SMEs of our data pipelines to come back, spend hours together debugging the data issues. Instead, whoever knows how to use the triage dashboard now can get an understanding of where exactly the data pipelines are breaking. Well, now we know how to identify the exact data pipeline that is impacted. But sometimes our journey of root cause analysis does not stop there, because there can be issues with a particular data pipeline due to the problems with any of its upstream jobs. Now again, the complexity of the problem has increased to a great extent, right? Because there can be several jobs to the upstream of a given job, and we rarely have any visibility into our upstream jobs. Now, how do we solve this? So we decided to solve this by getting an understanding of end-to-end data lineage in our ecosystem. And that is with the help of the metadata of our jobs, the tables, and the dashboards. We glued all this information together and called the solution as superglue. This later emerged as one of the most popular solutions within Intuit, and we are very happy to call out that Intuit has even open sourced this framework, so feel free to go back and check this out and contribute back if possible. Well, now let's get back to data lineage tracking. So here you can see the data lineage tracking done for one of the tables in our ecosystem. And now the question is, how did we achieve this? So we have the scripts related to our data pipelines in our GitHub repositories, and these pipelines are built on top of Spark, Hive, or any other data MPP platforms. We use SQL parsers to derive the relationships between the jobs, underlying scripts, and its input and output tables. And similar parsing is done for BI dashboards as well. Now, this way, we are able to understand the end-to-end data lineage within various components of our ecosystem. But Superglue also helps us with various other aspects. It helps us with identifying the job level statistics. It keeps track of the job execution metrics, the logs, and also the volume of data processed by each job to understand any anomalies in these sectors, which in turn is helped to identify what will be the ETA for the job completion, and also gives us a fair idea on whether or not we are going to meet the SLA for the day. So this way, we are able to have a great understanding as well as the control over all our jobs and the data. Now with that, let me summarize the data observability measures at Intuit. The principle here is that if we want the right data to be consumed, it is important that we identify any data anomalies proactively. So we have the SQL and ML based validations. We do the trend and volume analysis of our data. And again, if we want the right data, it is important that we monitor our data processing jobs. And there comes the data ingestion job monitoring section. So we have the benchmarking of our jobs done, the performance tuning done time to time, and we also have the alert set for long running, delay, and job failure scenarios. Even after having all these in place, if there are any issues with our data or with the jobs, we have the data lineage and data discovery tools available, which help us quickly identify the root cause and fix it later. Finally, let's take another look into data processing platform at Intuit. We saw it earlier with all red flags in place, but now since we have the solutions, all of them have turned into green. In the source layer, now we have the parity checks to identify the event loss, source job failures or the delays are identified, and we have numerous data quality checks in place, and also we are able to identify any anomalies within our data before the reporting layer itself. And now we see that improvement in the forecast models with the improvement in the quality of our data. Well, now let's ask Lisa again on what does she think about our data. You can see the bright smile in her face, which indicates she is happy because now she trusts our data. So now looks like the data observability measures that we have taken has really paid off, and our customers and the users are really happy. And where do you think our journey is going to be from this point?
Well, Pallavi nicely summarized on all the measures we have taken and how we have achieved data quality in Intuit and how our customers are happy now. But we are not stopping here. As you know, like there are a lot more to do as well to reduce the false positives and noises that we have in our data quality checks, and to introduce proactive identification and fixing of data quality issues and self-healing pipelines and many other things to grow. But still, that's a long journey to go to achieve operational and engineering excellence, and we are on it. Thank you all for listening.
Okay.
So my question is, I know signups and jobs done daily. Data quality checks you introduce in each layer, right? Just want to understand on a daily basis, how many alerts, because in product level changes keep on happening, right? QBO, payroll, TurboTax, all those things, right? On an average daily basis, weekly basis, how many alerts you get in terms of quality checks or in terms of any validation across those green boxes to set across?
Yeah. So to begin with, we have multiple set of alerts there. The first is actually the pipeline level alerts itself. Like if something fails, the pipeline fails and people are notified. And in the data quality checks, like there is a circuit breaker for sign-up sensors. Thing is, like if there is something broken over there or the data is not right, we actually get the circuit breaker failure over there, and we need to go back and fix it. And this is actually ensuring like the analysts have not fed with wrong data, And I think, Pallavi, we have a couple of times we had some checks in the last.
Right, yeah. And we also see these long-running alerts most commonly, but whatever we see most commonly, we try to fix that as soon as possible. So this way we keep a lower count of the number of false alerts as well. Yeah.
And kind of this is coming down. Like the trend is like after all these things are in place, the possibility of getting alerts are also coming down.
Hi, I just have a question. So let's say, for example, if there is a bug in the code, like we can see like where it is failing, and then we can deploy it and test it out and kind of thing. So is this something like through observability, like are we trying to find what is the bug in the data? Or like if there is a bug or like something is missing, like you guys said, validation checks and all. And through that validation, what do we actually resolve? Like, okay, I observed it, like there is something missing in the data. And post that, like, what do we do? Like, we kind of said, right? Like, there is an anomaly detections.
Right.
And then we send it to the machine learning platform and then get the output. Like, yeah, any specific use case, like, which you can explain, like, a little bit, elaborate on that part?
Right. I mean, the one use case that we talked about, it was actually really happened in our system. Like our analyst came back and said like one of our metrics is not looking right, and that's when we added a check over there to understand. So there are multiple ways in which we do data validation. One is actually, as you said, a bug in the code, which for which we need a unit testing over there. Even we have an internal unit testing framework developed by one of the team member, and we should be using that. But this is not for unit testing to see whether your SQL queries are right. That you test it before you deploy, right? But what happens is like we might not be able to identify some of the edge cases over there. Or maybe your ingestion pipeline itself had an issue, or an upstream job actually didn't give you a data, for which your pipelines are not responsible for fixing it, but you need to notify it in advance so that these issues are identified early on rather than figuring it out in the last leg of processing. And that's the idea. We have the validation checks at the first level itself.
Check. That answers your question, right? We only have time for those two questions. Anyone else has any more questions? You can find Sona and Pallavi. Is that okay?
Yeah.
Cool, guys. Can you hear a big round of applause for them? Very well presented. Thank you so much for your time. Okay, guys, now it's time to see who has the quickest fingers here. I want everyone to keep your screens open. There's a few things that I want you all to keep in mind. That if you're using your phone and you're going to be attempting this quiz, don't switch over to other apps, all right? And everyone has exactly 30 seconds. So the design of the particular quiz is in a way where it's released to everyone at the same time, and the question closes at the exact same time. So if you miss your opportunity, pitch. Cool? Can I see all your texting fingers up in the air? Up, 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 up. All right, let's just stretch it out. Let that blood flowing, because I want you all to get ready for this. Are you guys excited? No. I think you all forgot. Are you guys excited? The woo is when I point. Thank you. All right, let's try that as well. Wow. The lunch is really getting to you guys. Okay, has anyone not yet registered or signed up? Because the moment we begin, we cannot stop. All right. Do you need any support? Sure. Abhishek? Can we just... Or... Sure. I'm guessing everyone else has the app ready. So, Madam Neha, is it okay if I let them know what the prizes are? All right. So the first place is getting a JBL speaker. Yeah, now everyone wants to get a ooh. All right. The second prize, or the second place, is getting an Amazon, Alexa Echo Dot. Yeah? All right, that's an Eco Home, so you can take another speaker which also does your personal tasks at home. And the third prize is a wireless charger, right? I need the team to confirm. Yes, that's a yes. Are you guys excited? So one of you could be walking home with either of these gadgets. Now, it's the same for the social media context, the LinkedIn one that you all are looking at.
So try to get the best well-written post, and by the end of the day, during the prize distribution, you will be handed over that. All right, to support me on stage with each of the questions, can we say hi to Mr. Ganesh again? No, hi. Come on, guys, even I also ate. Where's that energy? Can we say hi, Ganesh? Hi. All right, excellent. Okay, so everyone is at the page. Confirm my seat. Can everyone see that? Has everyone moved into that? Can I also have someone from the Unravel team to be here on stage with me, please? Can you also just sign in so that I can see what the users are seeing? Abhishek, could you just sign up on this as well? Ready? Okay, can everyone see the welcome page? Is it okay if I can just step up to your message? Yeah, so quiz, you all are submitted, you all are ready. Okay. There's an error? Yeah, that's perfect. That's the screen, that's the landing page that you'll have to be on. Yeah, there's a countdown timer, right? Can you scroll down? There's a countdown timer. You can hit play quiz. And once we hit the admin starts, it's going to get activated. Everyone's good? Everyone's ready? All right. Ganesh, are we ready? Anyone has a problem? Quickly. Yes, so yeah. So you've registered, right? So this is where the play button. So you're already part of this, and the quiz will open up. Is that right? Yes. Everyone has exactly 30 seconds per question to get the right answer. And also, make sure you all don't just tap by mistake, because whatever answer you tap, because there's just a 30-second window, if you tap the wrong answer, that's the answer that's going to get locked. Okay? So take a breather. 30 seconds is a lot of time, I think. All right, everyone's ready? Anyone else wants to take time to sign up? We're good? We're good? All right. And the first question is coming to you in 3, 2, 1.
You'll see in your screen itself.
You can see the questions on your screen.
You all are in this conference and you all don't know the answer. I don't know what to say. What is data ops? And time. That's the end of the first question. We've got 80% of you who's answered correctly. All right? So the other 20% happens. One of you have skipped it as well. So that's the nature of the game. All right, let's see how competitive you guys are. You guys getting a feel of the app and the question, how it's going to go? Are you all ready for the second one? I need a yes from everyone. All right, let's go. The question's appearing in 5, 4, 3, 2, 1. Hello. What is this you are discussing and all? Just because you're not... All right, fair play. You are making friends around you, so it works. And time. All right. So if you'll notice, we have a different dashboard here. What you all have is your end user dashboard. And who is credited with introducing the word observability? So 26 participants here have given it up for Shivnath. Let's make some noise for Shivnath. Let's go. The LED is too close to me. I can't read the remaining. There's Mate, and the correct answer is Rudolf Kalman. And 30 participants have got it right, so give a round of applause for them. No. Again, let's go. 30 of them got it right. They are one step closer to winning something here today. All right, are you guys ready for the next question? Yes? All right, I'll take that in 3, 2, 1.
It's all working fine.
And time. What is a data pipeline? Wow, again, 80% of you have got it right. Make some noise for yourself if you all have got it right. Good job, guys. This is getting pretty intense. I'm not going to disclose this at the moment. Let's keep that. Yes. All right. Are we guys ready for the next question? Yes? All right. In 3, 2, 1.
It's a not in the question.
Which of the following are not important? Three seconds, all of you who are trying to copy. And time. Looks like this was a trick question. Was it? A lot of confused faces. And wow, it's apparently not. 80% has again got it right. Can you guys make some noise for yourselves? And the correct answer is none of the above. That's usually how even I answer in an MCQ, I don't know. All right, moving forward with the next question. You guys ready? Full focus, I like it.
Network issue. Stuck with network. Sorry for the network issue. Network issue. It was a network issue. I'm sorry for that. It got disconnected.
No problem. What's the screen that's showing up for you guys? The question hasn't come up yet, right? All right, the question showed up. 24% of you guys have answered it.
I have no other option than to refresh this page. Let's see how it goes now. I hope it works. Yeah.
Cool. The next question, guys get ready, is starting in.
Network actually. That's an issue.
Please pay attention to your screens. Do not change the app. Do not change your tabs. 3, 2, 1. What came just after the summer of '69? And time. 21% of you have guessed it correctly, because I know this was definitely a chance. And how many of them genuinely knew this answer? There we go. All right, are you guys ready for the next one? 3, 2, 1.
And the question ends in 2, 1. Which among the following is a Dataops observability solution? And the correct answer is Unravel. And 29 of you have got it right, so make some noise for that. Good job, guys. The other 47%, the other 47 participants, I would have done the same thing. I would have put all of the above. So if you have done that, good job on that as well. Are you guys ready for the next question? I need a yes. 3, 2, 1. And time. Let's see what the audience has answered. Again, quite a split decision. Looks like a guessing game. But there are 22 of you who got it right. The correct answer for which statement among the following is true about core and task nodes in AWS EMR? The correct answer is both can run tasks, but only one can store data. Good job if you've got the correct answer. Everyone else, come on, cheer it on. It's getting competitive. We are at question number 8. There's just 2 more questions left for you. And it's starting in now. Five seconds left to answer. If you all want to look around and copy, this is a chance. And time. So the question is, Databricks cluster types are all-purpose, job, both 1 and 2, none of 1 and 2. So 50 of you have got it right. That's 60% of the audience. Please put your hands together for the 60 participants who've got the right answer. Now for the last question, all right? We need some intensity build up. So can you all go, oh, before he hits it, okay? Ready? Let's practice. I don't say, oh. Hey, what happened, guys? You all were so friendly with me like before lunch. Can we go one last time? Say, oh. And 3, 2, 1.
It already started off.
My bad, guys. Which of these is not a stage related to Snowflake? And time. 22 participants, that's 27% of you all got the right answer in the last question. So give it up, that's the end of the quiz. Did you guys have fun? No, I don't want head nods. I know that's the most Indian reflex. Did you guys have fun? Yes? No, louder. Come on, guys. Yes? Where's the Josh? Come on. Yeah. Where's my favorite audience? Perfect. All right, so the results will be announced. If you all have seen your name, don't get excited. The back-end thing will refresh itself and it will calculate, and Mr. Ganesh will let us know the leaders for this particular quiz. Cool. So up next, what do we have? We have another speaker, the final speaker of the evening that's going to come up on stage. But before I invite him on stage, I have a special friend with me. How many of you guys would like to hear one last round of beatboxing? Yes. And I have a special friend here with me. His name is Afsar Syed. Can we make some noise for Afsar Syed, everybody? This is a surprise even for the team. So this is Bangalore's best beatboxer. He's been on international channels as a beatboxer as well. So I'm very honored and happy that he can be sharing the stage with us. Quickly grab your mic. And we're going to do a quick 2-minute performance. Abhishek, we have the time? Awesome. Cool. Sure.
All right, so you've seen me beatboxing over the period of today. So just give a quick 1 minute beat and then let's jam.
What's up, everyone? How's everyone doing? Nice, perfect. So my name is Afsa. I'm a beatboxer. I mean, he already introduced me and all that. So I'm going to showcase some beatboxing. If you guys like what I'm doing, you can make some noise. If you guys don't like what I'm doing, you can still make some noise, okay? Yes? Okay, this is how we do it. I say 3, y'all say 2, 1, beatbox, okay? 3,
2, 1, beatbox!
Bounce.
Come on, let's...
Let's hear it for Afsar. All right, now would you like to hear both of us do something together? Yes? More energy on that. Come on, guys.
Come on, clap, clap, clap. Put your hands up.
Dataops Observability. Let's go for Unravel. Look. Guys enjoy that? All right, we gotta definitely end this session. Let's come back before the last session because I think Giri had something in mind for us to try. So you guys energized for the next speaker. Thank you so much, Afsar. We'll have you back. Can you hear it one more time for Afsar Syed, everybody? Abhishek? Just need that screen. To this entire conference. So Hari is a senior software engineer at Unravel Data Systems. Previously, he collaborated with Oracle in Bangalore as part of PeopleSoft plugin development team. Also, the session which he's going to be taking for us is on lessons learned while migrating data pipelines from enterprise schedulers to Airflow. And Hari is getting his sound check ready.
Can everybody hear me? Does it work? Yeah, I'm audible, right? Yes. Okay, okay. I'm not sure how I can follow that, what happened right now. But yeah, I'll give it a shot. So just to introduce myself, right, I'm Hari and I'm working in Unravel itself. And these days, a lot of what I do is essentially trying to bridge the gap between our customer use cases and the data that we collect in Unravel today. So kind of, solutioning, conceptualizing, designing solutions that, can really leverage the potential of data that Unravel collects. We do a lot of things already, but we are still, I'd say, scratching the surface with the data that we have in Unravel. So really trying to bring out its full potential. So today, the talk which I'm going to give is the lessons that we learned with working with customers and helping them, migrate their data pipelines from on-prem to the cloud. And I'll try to tie in how data observability comes into the picture in this entire thing. Let's keep this interactive. If you have questions or comments and all, please feel free to offer them. Nobody wants to be the last person asking the last question to the last speaker of the day. So yeah, let's just do that. So let's begin with what is a data pipeline. We answered that question in the quiz. I got it wrong because I didn't see all of the above question option, unfortunately. But a data pipeline, to put it very simply and to borrow some analogy from Anuj's presentation, right, is something that can, convert data into information, which can be then further utilized down the line by other stakeholders to convert that information into knowledge or wisdom and stuff like that. But essentially, a data pipeline consists of these 4 or 5 bins that we see, right? There are these stages where we look at capturing data, storing data. So we have to ingest data, we have to store data. Then we run some transformations on them to kind of, process that data. Then we upload that transformed data into structures that are optimized for delivery and stuff like that. And finally, there are the stakeholders at the end of the pipeline, which actually consume this data and come up with, these applications that we use, these dashboards that we use, so to say. So one very pertinent point that was made in the panel by Govind, right, is what is this need of data observability, right? Why are we even here today, right? And that's because each stage, everybody here today, I'm sure, has worked on certain aspects in this pipeline and is here today because of that. But we tend to work in these silos, right? The world has become so decentralized, I'd say, right? And microservice layers and all that. Things are not like, squished into one box, which you can just take a look and, figure out everything. So it's really becoming very difficult because everything is so containerized these days that it becomes very difficult to try and trace or root cause a problem that's happening. To use an analogy, right? I'm sure all of you are, some of you are familiar with the fable of the 7 blind men and the elephant that we say, right? Where each blind man is given one part of the elephant to kind of touch and then ask what is that thing. So some people say it's a snake, some people say it's a trunk, a tree trunk, some people say it's a spike based on what they're touching, but nobody actually knows it's an elephant. And that is essentially what a data pipeline is also today. It's like nobody knows the pipeline. It is the elephant in the room when we talk about it in this question and context. So that's why, at least in my opinion, where observability comes into picture is trying to stitch together all these components together and create a unified view of the data pipeline. So yeah, so today many enterprises are modernizing their data stacks and their pipelines. So but what that means essentially is that people are migrating towards the cloud, right? And there are a lot of things that are prompting this decision to migrate towards the cloud. So I wouldn't say that everything is going to migrate to the cloud. So there's still going to be some code, say in the banking domain, which is low level and mission critical, that's always going to stay containerized in their own cluster, probably written in COBOL, right? It's not going to get migrated to the cloud. But more and more, there are, today's use cases, today's the way the world is evolving and the rate at which new use cases are coming up, the cloud architecture seems to be the place to go, and companies agree with that that intuition and they're following it, and a lot of companies are migrating towards the cloud. Some reasons why these companies migrate towards the cloud is that currently, like, we have this large kind of static clusters, right, where we have multiple tenants running, multiple apps running, and it becomes a pain to kind of partition resources between these clusters and, then provision resources for these clusters. Another important reason is that agility is becoming paramount right now. It's become very important to really get out, especially if you're a direct-to-consumer company. It's important to really be very reactive, and the cloud is a good way to do that. And scaling issues, of course, right? So it's like to add a new node to a data system is probably much difficult in an actual data center as opposed to just, provisioning a new instance fleet type on EMR, right? So that's where, why people are moving to the cloud. I'd invite you guys, if you've not really listened to this talk, it's a talk by Disney's Hotstar team, essentially, which was responsible for provisioning the infrastructure for the matches that run live stream, right? So it's a live stream match that runs, and especially if it's an India versus Pakistan match or something which is going to come up, right? You don't know the amount of users who are going to be online. It's like astronomical in number. So you have to kind of build systems that can actually, really take care of that and can handle that kind of load. And it's a very interesting talk. It's a very insightful talk, and the decisions that they make to actually build that. So it's something worth checking out for sure. I won't give it away, but ironically enough, something that came as a conclusion is that they decided to not go with AWS's auto-scaling approach because it was too slow for them. So essentially what happened is that they provisioned certain instance fleets and kept them warm all through the match. So that in case there was a surge in usage, they could easily be slotted in. But yeah, those are the kind of interesting decisions that people have to make, and based on the use cases that are coming to this. So that's very important. So what we are seeing, right, is we're also seeing an architectural shift when we are kind of designing our cloud approach. So usually it's like, huge pipelines running on the cluster, but now what we're seeing is that if we can identify a pipeline, right, usually what customers do is that they will allocate resources for just that pipeline on the cloud. And it's like, you can provision a cluster that is dedicated to run a certain pipeline on the cloud, and that turns out to be cheaper in the long run. So yeah, these are the goals of modernization or migration, right? Is to improve agility, and then resources are no longer a constraint for you, right? So you can spin up as many number of resources as you'd like to, and you have to reduce cost. So that is also an important thing. Like we only think about cost when we come to the cloud, right? But it on a data center, when you have to provision a proper data center, right, you always have to plan for the worst case possible, right? So it could be like the worst case only occurs 20% of the time, but still you have to plan your data center accordingly. So, but in the cloud, thanks to auto scaling, dynamic scaling, and other such concepts, right, you can actually have a more sensitive provisioning strategy towards this. So that's why doing things in the cloud is like could be cheaper if done properly, of course. So there are two main phases of this approach, and these phases are not like set in stone. It's actually an iterative process. Like there are the two phases itself are assessing and planning, and migrating while validating and optimizing. What this means essentially is that you eke out a strategy based on certain parameters, then you implement that strategy on the cloud, you validate that strategy, and then you take the feedback and you then again assess and plan, and then you again continue the cycle until you get it right. So where does data observability fit in this entire thing, right? It's in the second phase essentially. It's like, there I'd say that if we build out solutions, build out concepts that are instrumental in data observability, it becomes a lot easier to kind of benchmark and very concretely define such benchmarks and make sure that we are doing the right thing. And that's where I'd say observability comes hugely into the picture here. So yeah, so this assessing and planning stage is for sure extremely important. Like if you are a business owner or you are a team, a department owner, and somebody comes to you, right? and asks that I have to migrate all your pipelines to the cloud, right? So you have to go through some form of this assessing and planning phase. These are the core stages that we have kind of seen that happen, the entire process what it takes. So there's a pipeline discovery phase, there's a resource usage analysis phase, there's a dependency analysis phase, there's a complexity analysis, and then you're mapping to the constructs in the EMR, Databricks, or wherever you want to migrate to in that world. Then you do effort estimate, then you do a cost estimate, and all those things. Out of all these stages, right, the most instrumental or the most important stage that is the pipeline discovery stage. Because unless you don't know the scope, the breadth of what pipelines you're actually running, right, this entire migration is a failed effort in the beginning. So you have to be as have as comprehensive of a picture of the pipelines that you're running in your org, and that is not by no means a trivial exercise. Like the stuff which we have done is like we have to really go and introspect the code running, like the previous speakers, Pallavi and Sona, which they showed the data lineage analysis and all kind of comes into picture here, wherein you kind of look into the code, you try to figure out what are the input tables, output tables, you build a dependency graph, and then and from there you kind of start maintaining a catalog of these pipelines that we build, and you keep it as your benchmark essentially, which you can then validate in the future. So this is an example where where how observability comes into the picture, right? Is even in this phase, for instance, right? It enables a fine-grained tracking for that enables proper planning, right? So this is actually the Unravel UI that you see here. It's an older version of the Unravel UI, but yeah. So what we see here essentially is what Unravel displays as metadata and information for a particular Hive query that is run. So we have some metadata about the user metadata, like what queue it ran, what DB it actually talked to. So this is essentially here, right? The Hive user ran this in this particular queue, referencing this particular database. We know this is actually run as part of a pipeline because Unravel has internal mechanisms to identify that and correlate that. And then there are some resource usage KPIs, right? Like the time it took, the IO it did, right? And apart from that, Unravel also stores, because we get the query text and all that kind of things which they already talked about, right? It's like we parse the query text and figure out what is an input table and an output table. And those are two key concepts when we try to build a lineage graph essentially, right? So where if you know the input table of a Hive query and an output or table of a Hive query, you can kind of create this simple graph abstraction, right? Wherein the app is in between because it is the conduit between the two, and there are certain input tables and there are certain output tables. So what happens is that you get this kind of a lineage graph. You kind of if you build out a particular pipeline, right? I'm sure none of you can read it, but even if you could, it would be of no use to you because these things become so complicated and so complex. This particular lineage graph is probably of a customer pipeline which had like 3 or 4 tables and 5 or 6 steps in it, but it's like it is humanly viable to make sense of such a complicated lineage graph that you see. But how it can actually be utilized is the graph data structure underneath it, right, is very useful, I'd say, essentially, because that can be used not as a visualization technique, but as a validation technique, essentially, or as a knowledge retrieval mechanism, where you can use this as your knowledge base to query and figure out, what are my input tables, what are my output tables, and stuff like that, which come into play in the second phase, essentially. So yeah, I'd like to talk a little bit more about the migration execution strategy, right? So we have seen both of them. There's not a right answer, a wrong answer in this, but we do see that certain customers they kind of value the applications first, as in I want to migrate my more complex applications first, so that we can really do the tough, difficult part first. So that is one strategy where you kind of take your compute heavy apps and you really focus on migrating them first. The second kind of strategy is a more agile strategy, the one that you see here, where you want to hit the ground running essentially. So you want to really migrate your most popular or most commonly used data sets first, not the apps actually, but the data sets first, so that once they're on the cloud, then people can start using them, right? So that's another strategy that we have seen customers using. And it's actually completely predicated on business priorities and business needs, actually whatever strategy people use. But yeah, both of them we are kind of seeing happening in the field pretty much. Then we come to the second stage, right, which is more or less validating what we have done once migration is done. So how do we do that? So I'd say the way we do it essentially internally is that we consider three criteria: correctness, performance, and cost. So I will go quickly into those three criteria essentially. The first criteria is correctness, which is an important thing, is data quality. Somebody during Shivnath's keynote made a comment, right, that data quality is kind of a silent killer, as in, because nobody cares about data quality per se as long as your SLAs are met, right? Means because of the silo and decentralization and what we talked, right? Nobody really knows what's running. At least the stakeholders or the leaders, business leaders don't really know that. So it's very important to have technologies or solutions infused into your pipeline that can do these quality checks online or during runtime. And one of the tools that is out there in the industry is Great Expectations, which you can integrate to your pipeline, integrate your data set essentially, and lay down rules. It's basically a rule-based engine. That is, you lay down your expectations, and as the pipeline runs and as a data set is made available to the pipeline, it will essentially validate that, and based on that, send out alerts and all that. So correctness is a very important thing to kind of assess how well your migration is done. It's very important because you need the correct data, right, at the end of the day. So whatever happens, that is non-negotiable. So once you migrate, correctness is very important to enforce. The second is performance. Of course, that's the most popular out of all these three, is that your SLAs need to be met. Performance by itself is something that can be observed or monitored pretty easily. It means most orchestrators that you use have performance SLA monitoring kind of built into it. So if you have been using Uzi, which is an old Hadoop kind of orchestrator, that has the SLA tag in your workflow XML that you can use. Airflow has an SLA field in your DAG, which you can use to kind of set these SLAs and all. So essentially performance, I'd say SLA monitoring as a concept is available in many orchestrators around the field. And Unravel, of course, has support for such orchestrators. So we can always monitor SLAs and do things. Something that Unravel does, I'd say, slightly bit extra is that it can also do baselining. So based on which also some orchestrators do. But it can do baseline, and based on that, can help point out anomalies in certain runs and stuff like and things like that. And finally, since we are on the cloud, right? So this is probably the most not popular, but this is the most important thing that business leaders care about, right? Are your costs out of control? Are your costs in control? So Unravel has this entire budgeting section where you can go ahead and set your budget limits for your pipelines, and then you can track them. There are other solutions there also which can do that, but this is the third thing which business leaders or similar people will care about. So correctness, performance, and cost are three things that we essentially look at once we kind of migrate a pipeline from the from on-prem to the cloud. So I don't have a demo actually because this was on short notice, but I have kind of cobbled through a few screens on the tooling that we use within Unravel to kind of do data observability per se, right? So, excuse me. So one of these the tools that we'll talk about is something that can send alerts to say a Slack channel, right? So we'll just go through three scenarios where the first scenario is that Unravel can send you an alert saying that there's a pipeline which is in danger of missing its SLA. Then there's another pipeline which is in danger of, say, overrunning its costs, right? And there's another pipeline that has data quality issues. So how do we kind of achieve these three alerts, right? So this is kind of a dashboard that we can build, right, based on the data that we collect in Unravel, right, where we kind of go ahead and see, right, there's this particular pipeline, the reporting insights hourly pipeline, right, which has run, and we see that the run of this particular pipeline was around 8.5 times slower than a particular baseline run that we kind of defined for it to be. So we see that this pipeline took almost 5 minutes to run. These are in milliseconds, and usually takes less than a second to run, less than a minute to run, I'm sorry. So the problem is very clear by looking at this, that this particular pipeline is going to mess this SLA. So what is the next step to do, right? Is that you could go to the Unravel UI by, say, clicking this link, right? Check cluster activity, which actually directs you to the Unravel UI. And you see that this running insights, I apologize, I'm not sure if it's really clear on the screen or not, but this reporting insights hourly pipeline, right? Even though it's a Spark job, it has not actually started running because this is an ad hoc job that is running on the cloud cluster, which is actually taking up the resources, right? Which is which is somewhat common in the cloud that we see. It is in nascent stages of migration. So what happens in such a scenario, right? Because some other thing is taking resources on the cloud. Since this is a cloud environment, it would make sense to spin up a cluster either dedicated for the reporting insights hourly or for the ad hoc BI, so they can be kind of decoupled and both can run properly. So you should not really be mixing ad hoc applications with your pipelines, especially if you're on the cloud. The second use case that we see here, right? Sure. Could you please speak a little louder, please? I can't hear you. Yeah, so those are essentially what you're saying are quality checks, right? in the pipeline. We'll get to that quality checks thing, and we can see how we can integrate with quality tooling out there already, essentially, and have those things beamed into Unravel and let Unravel serve you as the single point of glass to look at everything, essentially. I'll just get to that in a minute. So yeah, so the second kind of use case that we saw, right, is a cost overrun use case. So how do we even know that? It's like Unravel tracks the cost of the pipeline on the cloud, right, based on AWS or Databricks or wherever you're running. So we see that this pipeline essentially did $12.50 worth of cost. Its baseline, or what we kind of envision it to do, is around, say, $2.50 or something. So there's a significant deviation from the baseline. So the next step on how to kind of introspect and see what's going wrong, right, is we can provide a kind of a Gantt chart view of the components that ran as part of the pipeline, essentially. So if you see the two reviews, the one on the left is the golden run, so to say, and the one on the right is the present run, the baseline versus the target. So you see, it's very clear just from seeing this that the target had additional components that ran, right? Which probably ended up taking more resources or time, and which contributed to the cost. But this thing, so these are the concepts in observability when you talk about, right? It's like you can see this in a single pane of glass, that there is something in the pipeline which is probably doing something different. So what might have happened in such a use case is that developer might have gone and made a change in the code, right? Or probably the pipeline behavior changed based on certain requirements, and which is why there was a change in the number of components that actually ran as part of the pipeline. So such things are okay to do on an on-prem cluster where your costs are more or less managed, but on the cloud, if you make such changes, one should be slightly wary of doing that, because it could lead to really cost overruns and things like that. And finally, to get to his question, right, on what about enforcing quality checks within the pipeline. So we currently, what we do is that we support, or we have such a architecture wherein we can essentially receive event-based notifications from other services out there, which can do quality checks and all. One of them is, like I said, Great Expectations. So in this particular case, we see that Great Expectations sent Unravel a notification saying that, this particular pipeline, this, this particular data asset in that pipeline, which I'm not sure if you can see, the customer table had certain expectation validations that were not met. Very specifically, the row count should be less than 10,000, but it was around 19,000. So all this work is essentially done in Great Expectations as part of their rule engine. And you can integrate to that by creating a package in Great Expectations, your own package also if it's custom, if you'd like to do that, and which can send information to a third-party repository, which can then store it and show it here. So all these three examples that I showed, right, are something to do with data observability at the end of the day, and how it can be used to kind of migrate, to assess your migrations specifically in this case, but it holds true for other use cases also. This is kind of the what we want to do with data observability, right? Has everything in a single pane of glass and make it very easy for the life of anybody who's actually trying to monitor data pipelines. To kind of tune and troubleshoot the pipelines, identify bottlenecks, and mitigate costs. So yeah, that's pretty much my time. I think so I'm already taken up all the time. So yeah. Any questions if there are? Okay. Thank you.
All right, thank you so much, Hari. Guys, come on, let's give a bigger round of applause for Hari. Very insightful and great presentation being prepared at such short notice. Okay, guys, so that was the last speaker for the evening. So give yourselves a round of applause. Amazing day, great food, brilliant panelists, a lot of fun, a little bit of beatboxing here and there, right? So now we're going to move on to the prize distributions. So let's get to see who are those lucky winners. And before that, I'd just like to take a moment from my side to really thank Unravel Data and Conference Hub for organizing this. Come on, guys, put your hands together for that. Also the community partners, JetBrains and the Fifth Elephant. Let's hear it for that. Yeah. Cool. So before we start off with the prize thing, I want to give you guys a small gift, which is the art of beatboxing. Are you guys ready? Yeah. 3 simple sounds I want you all to try with me. Cool? We've been doing this as children, so don't feel awkward. If you're feeling awkward, you can cup your mouth like this. All right? So that whoever's sitting in front of you is like, why is it raining inside? All right? So you're going to keep your mouth like this, and the first sound is going to be... Yes, just like the motorboat. Everyone participate. All right, the second sound is going to be like a tire going flat. Oh, a lot of participation slowly increasing. Awesome. The third sound, very, very core to our Indian culture, when there's too much work. Oh, this everyone wants to do, right? Okay, awesome. What's the first sound? Second sound. Third sound. Awesome. Now you're going to do it all together. Repeat after me and let's see how this goes. You ready? Give yourselves a round of applause, guys. So you'll practice these sounds and you're going to get there, and I'd like to move forward with first honoring the speakers of the day. Could we give a big, and I'd like Shivnath to come up on stage and present them with a small memento. Oh, I'm sorry, I slightly messed up. Shivnath, just give me a moment. I'd like Neha and Swati to come and honor the guests. No, we'll get Shivnath back for something more fun, right? More fun, yes. All right, can we have Swati and Neha? Can you guys give a round of applause for Swati and Neha? All right, can we have our speaker on stage? First up, I'd like to call upon Anuj Gupta. Come on, guys, keep clapping. Let's hype him up. Anuj. Probably the most informal conference you'll have had, yes? Was it more fun? Okay, thank you. Thank you so much, Mr. Anuj. One photo, please. While they get that picture, can we make some noise for Sona and Pallavi to come up on stage? Can we have Madam Neha come up with this beautiful bag? We also have Sanuj supporting. Okay, I'll help him out. Come on, guys, make some noise. Brilliant work, guys. I'd like to give off to Pallavi and Sona. Great job, guys. Sometimes my phone doesn't recognize my face. All right. Up next, can we have back on stage Hari Nair? Hari, come on. Hari, Hari, Hari. We have Swati hand him his token of appreciation. Thank you so much, Hari. Now can we have the esteemed panelist to step up on stage? Can we have Mr. Chandrasekhar? Yeah, come on guys, keep the hype going. Could you take a picture? Yeah. While they pose for that, Giriraj, Bagdi, everybody, come on, high energy. We have Swati presenting him with a moment of token again. And last but not least, the professor himself. Can we hear it for Shivnath Babu to step on stage to receive a token of appreciation from the entire conference. Yo, come on guys, give it up, give it up, give it up! Okay, now I would also like to re-invite Shivnath, sir, please back on stage, because we would like you to honor the winners of some really cool goodies, right? Dude, what more can you ask from a conference? Amazing learning experience, brilliant way to network, a lot of collaboration opportunities, great lunch, great coffee and tea, and right now, some really good prizes. Are you guys ready to know who won what? Yes? Okay. Small technical issues. But in that meantime, how about everyone look to the person sitting next to you and introduce yourself real quick. Hi, hi, if you already know each other, look back. You all have never met each other. This is the opportunity. This is the networking part. I want you all to go get out of here with a lot of friends and a network. So I don't see the both of you introducing even though you all know each other. Cool. Then Mr. Anuj, the person behind you, have you met him before? Yes, okay. Some very close clustered groups. I should do that class teacher thing. Hey, you go sit there, you go sit there. But, we don't have the time. We have the prizes ready. JetBrains, Cupid. Okay. All right, what are the prizes? Okay. This is? Okay, so we're going to go on with the quiz winner. This is 3, 2, 1 is how I'm going to go. Third place first. I'm going to be calling out the third prize first. All right, I want everyone to do something called as the drum roll, okay? This is how you're going to go. You're going to tap your thighs. Da, 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 da. Faster, faster. Oh, and in third place, we have Karthik N.A. Can we hear it for Karthik? Good job.
Prices causing pressure this Diwali. Split them in 3 with no cost EMI and big discounts on the clear.
Congratulations on your wireless charger. Yo, make some noise, dude. That quiz was pretty difficult, right? All right. Okay, again, drum roll, please. And in second place, we have Avik Mishra. Congratulations on your Eco Dot. Congratulations, Avik Mishra. All right. And at first place, are you guys ready? Okay, I need your thighs to hurt with the amount of intensity I'm going to give because that quiz was really difficult. Come on, guys. 3, 2, 1. Oh, and it's Umakant. Oh, let's go. You got a JBL speaker. Congratulations, Mr. Umakant. Keep those applause going, guys. You all took part. You all knew how difficult that was. So he's the conference topper. And also, Mr. Umakant, there is a special additional gift that you're getting from JetBrains. They're giving you 1 year, right? 1 year to JetBrains. So congrats on that. They will be reaching out to you on how you can access those details. Okay, so the next set of awards that we have, thank you very much. So whoever took part, just took part, okay? You literally have a chance. Yeah, let's get it from Giri. Come on, make some noise for Giri. See guys, that's why I kept trying to tell you all, like, secretly, you just put one post, type whatever you want, because you know why? It's a lucky draw. And it's going to get super interesting because, okay, sorry. I thought when I turn, it'll coolly appear.
1, 2, make sound guys, come on.
As usual, you know, whenever we go to conference room, that projector won't work. Some small technical difficulties. And we are here. Okay, so how many participants we have in total on this wheel of fortune? We have 23 of you all. Guys, you have a 1 in 23 chance of winning something. So if you had put your name, put up that social media post, this is your opportunity. Okay, are you guys ready for the first spin? Yeah. And the winner is, this is for 3rd place, Rishabh Dev Manu. Make some noise. Where are you, Rishabh? Congrats on your gift right there. Could you guys come to the center right here? Rishabh Dev Manu, please smile. Amazing. Good job. Thank you so much for that. Are you guys ready for the second spin? Now 1 in 22 chance. All right, 3, 2, 1. I'll give you, bro. I'll give you my number. Harsha Madhur, congratulations on winning the Eco Dot. Let's go. What an amazing event this is. Thank you so much. And the grand winner of the social media LinkedIn post lucky draw channel, it could be you, my friend. It could be you. Let's spin it. Vishwan! What? Okay guys, the universe works in mysterious ways. This is not rigged. You just earned something more than my number, so that's a fist bump. Okay, he wants to go for a hug. Cool. Super excited. This is the kind of energy you bring into a learning conference. Let's hear it for Vishwas! Dude, I think he just won the Golden Globe Nobel Prize. I just did the fist bump. Scratch, my bad. Thank you. Next, winner speech.
Thank you, God, for this opportunity. Thank you, Unravel, for this great conference. Great food. And this means a lot. I'll keep this in my room. It will be always connected to my phone. Thank you so much.
Congratulations, Vishwas. A lot of energy. Well-deserved winner for sure. All right, this concludes my time with you all. I'm going to be handing over the mic to Mr. Giri, but just before that. Cool, you wanted everyone to do something, and I also want to see them do. Can everybody just stand up real quick? Come on, guys. Up on your feet. It's been an amazing day. Let's stretch those legs. I'm going to be doing the sounds of our Indian music as the final set. So, simple steps. Shake your leg. Move a little bit. Can I get that from you? Yes? Okay, how many of you know how to whistle here? If you can whistle, fully send it because this is the most hooligan you can get at a very formal event. Okay, we're going to go down south.
That's the Urmi. I want you all to move. Put your hands up. Move faster. Thank you so much, ladies and gentlemen. Once again, my name is Sunil Suresh, and I'd like to invite Mr. Giri.
All of you to coming here, and it's one of the great first conferences we did. We'll do more over it. We'll announce a meetup group also today. And how many of you guys made 5 new friends? Right? This conference is about networking, making 5 new friends, learning, going back to your home and apply all the learnings, right? Thank you so much. And by the way, thanks to Sunil. I mean, what an amazing MC he had been. Thank you, Sunil, so much.
Once again, while now we are going to be breaking off for a tea and networking event, once again, our final beverage together will be outside in the lawn area. Make your way out, stretch your legs. Thank you so much for being part of this amazing conference, which is happening for the first time in India. Clap hands one last time for all the teams that were working on this. Big ups. Thank you so much to all the sound, light, and visual team. Thank you so much. Mega Nandri. Until next time. And also, if you want to support me as an artist, you can follow me on Instagram at Sunil Suresh Official. Okay, that is at Sunil Suresh Official on Instagram. Thank you so much.
So folks, can all the volunteers come here? Neha, Swati, Richesh, Sanuj, Abhishek. Let me show you your faces behind. Come on guys, volunteers, Deepak, Chandra, I know you here. Guys, come here on the stage. Volunteers, please. Who you are? I know you are.
Come up, guys. Come up. Everyone in the
Volunteers, let's
organizing
start.
team.
Where's Abhishek gone? Come on, guys. Come on, the volunteers on the stage. Let's meet everyone. Quickly. All right. So, folks, it takes a village to get a show out of the door. And definitely thanks to all of these folks, right? A big applause to everyone. All right. All right, come on. Should I have a picture with everyone? We don't have a picture. I might up today. Have a picture with everyone. All right, guys. Here, my heroes. My heroes. Okay.